some more announcements. So really to get started here, our goal in OAC is really to transform the research ecosystem through, okay, the meeting is being, no problem. There we go.
Sorry.
Okay, our goal is really to transform science and engineering research through an integrated cyber infrastructure ecosystem. And what is so interesting and I think really impactful about OAC's portfolio is there's really this range of awards and research that are supported, from really basic and core research into cyber infrastructure, but also workforce development awards, building communities, and then the largest scale computing, data, systems, and services at our universities that are made available nationally. And so our portfolio is kind of divided into these buckets here. And what I've learned from being at NSF for about a year is these are not completely clean boundaries, but you can see the categories: advanced computing systems, networking and cybersecurity, our learning, course development, core programs are in there, software and data, and then a set of what we call strategic investments, and those can change from year to year based on the agency's priorities. And so maybe you all know this, but I think it's worth just repeating that OAC supports systems and services for the research community that are, I would say, free to the researchers. They're funded by NSF, and you can get access to systems, services, software, and user support through the Access program, and access quite a few different high-performance computing and advanced computing systems. I'm always surprised when I go out into the community how many people really aren't always aware of these resources that are available to them. This is, and these are actually some of the resources we're building on for the NAIR. Then OAC, we also make campus and regional investments through our CC Star program, and then also fund and support international network connections and regional networking as well. And then there's a number of services and communities that OAC supports as well. PATH, right, is the partnership to advance throughput computing. Cloud Bank is a way to access resources that are from commercial cloud providers. There's a number of centers of excellence, for example, Trusted CI or CI Compass. And then again, we support a number of communities, such as the Minority Serving CI Consortium or the AHEC Computing Consortium. And so I thought I would do a couple highlights from FY24 here. And so the first is some new awards from the Skype program. Skype is strengthening the cyber infrastructure professionals ecosystem. There were 3 new awards. I'm just highlighting 2 here. I'm actually waiting for an image highlight on the third. But these are really interesting proposals and awards. And actually, all 3 of them come from EPSCoR states. So the one on the left is, these are great acronyms you all come up with. This is called Wild West, and it's using wireless networks to advance geo and field sciences. And this is from PI Strachan from Nevada. And the other is a new award led by the University of Delaware that's really creating a pipeline of research software engineers that are particularly targeting social and behavioral and economics areas as well. We have 2 new advanced computing awards. The one on the right is Cosmos, and this is a system out of the PIs out of the UC San Diego, and it's actually we'll use the AMD GPU. I think this is important to make sure that our ecosystem has architectural diversity in it. And so that will be stood up in this later this year. And then the award on the left is called MPAS. This is also a really interesting award that is investigating using renewable energy in order to basically run a system. So it has to think about the scheduling, not only from kind of that user or system perspective, but all the way through that power system at the data center. Skip that one. An award that is collaborative, actually across multiple divisions and directorates. It's called the National Deep Inference Fabric. And this is an award that is looking to provide the research community the ability to kind of probe and alter large-scale models. And it's a really unique effort in that it's going to require our access to OAC's computing resources. They're partnering with the Delta PIs here from NCSA. And it's really a new model and is going to require actually some real-time or dedicated support of some of the GPUs on Delta. So we're really working through some of those collaborations right now. And then finally, just a couple months ago, we, NSF made the award for the Leadership Class Computing Facility. This was an effort that started, nearly a decade ago, and will be the largest advanced computing system for the research and education communities. It's led by TAC, but there's also partners with NCSA and UC San Diego, Pittsburgh, and the Atlanta Computing Consortium. Okay, so I wanted to talk a little bit about some of our initiatives in OAC, and then I'm going to focus on one of them today, which is the NAIR. So one thing we've been really looking at, I'm going to walk through some of each one of these icons briefly before hitting on the NAIR. One of the things we've really been working on is looking at our ecosystem as a whole rather than as a series of individual awards. And I think this is really important to strategically see where the gaps are in our portfolio, the number of users we serve, and where we are missing communities. So that's something we're going to be at the end of this fiscal year. We're going to be reporting out on our ecosystems and computing usage as a whole to the community. That's actually also a deliverable in the Chips in Science. Been working on growing and developing the communities through workforce development. I'll talk a little bit about that through the NAIR. We have a number of new initiatives around integrating data and software. One of those is the National Discovery Cloud for Climate that maybe Amy Walton talked about yesterday. We're really also thinking about how we can make sure that the education and research communities are prepared for a post-Moore's law environment where the architectures are more specialized and you don't get necessarily the free gains that you had historically from clock speed increase. And then we're also working on some new partnerships. I'll talk about that in NAIR as well. Okay, so let's get to the main event here and tell you a little bit more about where we are with the pilot. I'm going to start with the vision for the NAIR. The vision is for a national infrastructure that connects the research and education communities to the necessary computing, yes, but also the data sets, the models, software, training, and really importantly, expertise and user support. And there was 4 key goals that were outlined as part of the vision for the NAIR. These were to spur innovation for the country, increase the overall diversity of talent in AI, improve the US's capacity for AI R&D, and to advance what's called here trustworthy AI. Sometimes this is referred to as responsible AI or transparent AI. And so, sometimes, people may ask, well, why do we need an NAIR? Do we already have a lot of large-scale computing and data systems in the country? And what we typically say is well, yes, we do have really large scale systems in the country, but they're increasingly concentrated into the largest technology companies or the most well-resourced institutions or university. And we know there's so many communities that can participate, and we need to participate in order to really advance AI research for the country. And so to take a step back on where we came from, this task force report was published in January of 2023. So, you know, approaching a year and a half ago. Certainly a lot has happened in that time frame. But then not quite a year ago, in October of 2023, there was a presidential executive order on safe, secure, and trustworthy AI, and that directed NSF and our collaborating agencies to launch a pilot for the NAIR, which we did in January. And our goals here were really, you know, the pilot is small, right? The pilot is small compared to the vision for the NAIR, which, you know, is roughly about a $3 billion initiative over a 6-year period. So it's a big initiative. What we're doing in the pilot is trying to, with a small amount of kind of seed funding and contributed resources, demonstrate the potential value and impact of this concept of the NAIR, supporting new research, reaching new communities, and then gaining a lot of lessons learned as we go forward. You can see some budget numbers that are public down in the bottom here. NSF invested $30 million this fiscal year to support the NAIR pilot. The budget request for FY25 is also $30 million. And then we had in-kind contributions from a number of non-governmental partners on the order of $80 million. And then agencies are also contributing their existing resources. And so what are we going for here, right? We're going for kind of a design where there's a set of researchers. These researchers need to be US-based, but they can come from a variety of institutions, nonprofits, universities, FFRDCs, tribal, state, local governments. And these researchers could be investigating kind of core AI subjects. They could be investigating different domain sciences and using and integrating AI into their research, or they could be students and educators. And they will access these resources, request them through a portal. You can see I call it our Lean Mean portal that's up now. It's managed by the SGX3 team and at nairpilot.org. And then that's where they can access this diverse set of resources from cloud computing, high performance computing, data sets, models, software, and user support. And so, right, I think I touched on this. Our key goals are to really reach some new communities. I mean, we know that this small pilot itself is not going to democratize access, but we in this pilot can show that we can reach some communities that haven't historically participated or used large scale or advanced computing. Can show how that could be scaled out in a full NAIR. We want to demonstrate some new and novel research that wouldn't otherwise have happened. So for you here in the audience today, I think what I'd like you to take away is that we have a number of opportunities that are open to you right now, okay? And those 3 are listed here. One is that you or your research teams can go to nairpilot.org and immediately request access to those computing model, software, collaboration resources. And I will say there are some really unique and interesting opportunities. It's not just computing that's up there. There's some collaborations with some of the partners that they're willing to, you know, and interested in partnering with different research teams. So definitely check those out. You can also contribute to the NAIR pilot with a demonstration project. And this, called, you know, a DCL, Dear Colleagues letter, is open still. I'll walk through these. The other DCL, Dear Colleagues letter opportunity, is called NAIR Pilot Expansion, and this is to build and expand the NAIR pilot community to communities we have historically not served. All right, so again, you can go to this portal right now. This is what it looks like. There's resources for classrooms and educators. There's resources for researchers. And then there's a set of kind of open opportunities or open data sets models that you can access here as well. And so thus far, the NAIR pilot is supporting about 115 different projects. New projects are announced each month. There's a review cycle that happens every month, handled by some of our awardees, many from the Access program. And if you look at these are just a couple of snapshots and vignettes of some of the projects. I mean, they're really exciting and inspiring. I mean, I couldn't have predicted any of these abstracts or titles that have come in. And so, what we're really aiming to do here with the NAIR pilot is really unleash and unlock the creativity of our research and education. And so you can see here, some of these projects are focused on really core, you might say core AI research topics. This one on the lower left, training foundation models from private federated client data from Julia Fanti at Carnegie Mellon. Another investigator from Utah, investigating whether model compression gives you the same kind of accuracy. And then you see a couple of AI research problems to apply to different domain sciences. There's one in the middle there from Iowa State that is trying to identify different agricultural pests. And then one over on the right called Lake GPT, which is in building a foundation model for aquatic sciences, looking at problems such as water quality. So in terms of the geographic impact, this is really important to us, is making sure that we are reaching communities across the country. So far, there are awards that are been given out to 34 different states. And so we're tracking this really closely. And I can say I was just on Friday on a call with a number of researchers from Nebraska, because that was an area of the country where we have not received any applications. And so we're going to continue to do this outreach and build awareness for the NAIR pilot. I would say, we're also very aware and looking at the types of institutions and where our research communities come from. And so this is just kind of a quick snapshot of these research teams come from R1 universities. That's the Carnegie classification of large research universities. I don't think that's surprising, given that they train and educate such a large percentage of our students. But we're starting to see requests from a number of smaller colleges and universities as well. When I ran the numbers a couple days ago, about 20% of the awards are to researchers from minority serving institutions, and about 10% of the awards are to researchers in EPSCoR states. Of course, we'd like both of those numbers to be higher, and we're going to continue to do outreach, and our NAIR pilot expansion opportunity is intended to help there as well. We also have the first 4 NAIR Classroom Awards that were just announced, I think it was last week. And so you can see these are instructors, professors, educators that have requested, typically it's like a Jupyter notebook for their classroom. And this is an area where we're really interested in learning more from the community about what kind of resources are needed in the classroom. I think we know that not every student is going to be able to train a huge model on the fastest hardware. We certainly don't have the resources to do that. But what we want to understand is, where can the NAIR really make an impact? And so these first 4 awards, they're on different AI topics. They're all public universities, but there's a variety of class sizes, right? From Southern Oregon University with 25 students that serves a local nearby tribal communities, and also this deep learning class from North Carolina State with 800 students. So this is an area that has really exploded since that NAIR task force. Let me tell you a little bit more about the demonstration project opportunities. The goal with these demonstration projects is to demonstrate the capabilities of a full NAIR. Okay, and so we're focusing on, pathways that will address specific AI research challenges, particularly from an infrastructure perspective. And so far, there are 12 demonstration projects that have been funded or contributed by agencies. They will be added to nairpilot.org. I believe there's 4 of them now, and they will continue to be posted as we get those vignettes from the research community. This opportunity is still open. Now, we have closed out our FY24 funds, but we have the ability to fund some in FY25. A couple examples of demonstration projects are here. One is this Pelican project, and this is really a project to work on data movement, to co-locate data and compute. There's the National Data Platform, and this is a demonstration project that I think of as a kind of a prototype data search and discovery system that also connects kind of a data set to the appropriate computing. And then SAGE is an edge computing demonstration that allows students to use this edge network, hardware and software infrastructure, to explore AI questions and streaming data in their local communities. So in terms of now let me move on to the NAIR pilot expansion opportunity here. And this is really to promote and diversify both AI education, workforce development, and to broaden access to these resources that are provided through the NAIR. And there's 2 tracks. There's one track that is targeting the research community, those researchers that are new or just beginning to, develop, use, or incorporate AI into their research investigations. Another track is for educators, and that is to build kind of a community around educators that are trying to incorporate AI into their curriculum. And so there's a number of communities of interest that I noted there on the right, whether it's rural institutions, EPSCoR states, minority-serving institutions, and sometimes the intersection of these institutions and researchers from these institutions who are really trying to reach here. Okay, well, now let me talk a little bit about data strategy with the NAIR. This is the Harnessing the Data Revolution conference or meeting after all. And so I think clearly, data is such a critical piece to AI research. And so the question, there's a lot of text here, but I'm just going to talk through. The question you have to think about is the NAIR is an infrastructure. So what role does the NAIR have in supporting, data for AI research? So I'm going to say a couple things that the NAIR is not envisioned to do, okay? So one of those is that the NAIR is not going to define strict data set standards, which, those standards continue to evolve, and they're really best defined by the community. It wouldn't really make a lot of sense for the NAIR, right, to set data standards for an astronomy or telescope community. That wouldn't work and wouldn't make a lot of sense. And the NAIR itself is also not going to, fund necessarily the collection or the creation of these domain data sets. Again, that expertise really lies with those communities. So what is the role for envisioned for the NAIR when it comes to data? And we can look to the NAIR task force report that was very thoughtful in laying out where the NAIR could have an impact. And so one of those was really setting guidelines and criteria for data set inclusion in the NAIR. Now, these are not like specific metadata standards, but really what are the guidelines and criteria? And we're working on this right now in our interagency steering group and really focusing on the value of a data set to a community, building communities around different data sets. The NAIR can support a search and discovery service. The NARE can serve to incentivize communities to contribute, analysis-ready data sets. The NARE can provide integrated computing and data platforms, can facilitate access to some restricted data sets as well. And then the NARE is envisioned to provide user support, technical expertise for communities that may be curating their own community data sets. And so where are we right now? I'm going to say that the data is much harder than the compute. We've been working on the compute for so many years in OAC and across agencies. What we have right now is that a number of agency data sets are available through the pilot. And I think what I can say publicly and have said publicly is that our NARE steering committee is developing and working on, criteria for how non-governmental data sets could be included in the NARE. Okay, I want to make sure I have time for some questions here. So I also want to talk about our collaborations with different agencies. So the NARE pilot has about 13 agencies, including NSF, that are collaborating, and that is a lot of different agencies to coordinate with, and the agencies are providing different pieces to them. So the Department of Energy is contributing access to their large-scale computing systems, as well as they are co-leading the NARE Secure effort with the National Institutes of Health, NIH. Other agencies like NOAA and NASA have contributed data sets to the NARE. Some other agencies are contributing software packages and expertise. So I wanted to highlight, I couldn't highlight all 13 here, but I wanted to highlight one or two. One example is NIH. They are providing, I'd say, integrated platforms that include data and computing platforms into the NARE. And sometimes these look quite different than some of our NSF assets, where a data set is funded over here and you can bring it because it's out in the open to computing resources in a fairly straightforward manner. In some of the NIH contributions to the pilot, these are integrated systems that target certain areas. And one is this N3C consortium that's looking at clinical data from the COVID pandemic. Another is medical imaging as well. And so NIH is really bringing a lot of expertise on how to support data and usage when the data needs to be protected very carefully. Another demonstration project we have is actually through the National Secure Data Service. This is a demonstration out of NCSES, which is the Statistical Agency on Science and Engineering Statistics within NSF. And in this demonstration project, NSDS, if you aren't familiar with it, they are working on a demonstration to provide, government-wide access to very sensitive data that is hosted by these statistical agencies, and provide the tools and the data linkage and access infrastructure for those statistical communities. What they found is that in many cases, a large amount of computing is needed because these data sets are getting increasingly large. And so this is a demonstration project to showcase the capabilities of the National Secure Demonstration Service to run on in a protected enclave at Oak Ridge National. So lots of really challenging policy issues that come in play when you're working with sensitive data. Okay, and so I'm just going to wrap up here with some plans, our plans to evolve the pilot within the next about year and a half. The pilot is it's a 2-year pilot, and so we're about 6 or 7 months into it. And so we want to continue to support and host a number of different workshops for the communities in different areas. We are planning to write kind of an interim report at the 1-year mark to kind of note and document our lessons learned so far. We're planning to have a NAIR pilot annual meeting in early calendar year, FY25. And then we're going to continue to reach out to new communities, build capabilities into the pilot, and integrate different resources. So with that, I wanted to make sure to acknowledge the amazing team at NSF that has been helping with the pilot. It is just a huge number of people, not only in OAC, but across the agency. This is a very big initiative for NSF from the director on down, and we have support from many people. So thank you very much, and I hope I left some time with questions, because that's actually usually the most interesting part for me.
Thank you for reading the solicitation clarify the issue for distributing funds for pilot projects.
Yeah, okay. So I want to make sure this is really, really clear. I put up 3 opportunities. One is for resources only. So that means there's no exchange of NSF funds. That is for requesting access to computing or models. Okay. You're nodding. I just want to make sure everyone else has that. The other 2 opportunities are, yes, NSF opportunities. And I think you have to read in detail, but there's an opportunity for eagers and supplements on the demonstration projects.
The second one, which was the expansion.
It's okay. In the research track, it's eagers, supplements, also conference and workshop proposals, a different category. In the educator track, conference, workshop proposals, also research coordination networks. So if you're not familiar with that mechanism, that's a really kind of interesting pathway that's already provided by.
Thank you. One question to follow up. Can researchers upload HIPAA protected data?
Yeah, so we have, there are a couple of the resources that are available for researchers that are HIPAA compliant. I wouldn't say we have a huge amount of capacity there, and I think we're noting that that is a bit of a gap, right? That's because you know, we didn't quite know what would come in from the research community. We are seeing a number of requests from researchers, and there are a few enclaves. Oak Ridge National Lab has an enclave. Their system is fairly full, but if there are projects that are of interest to them, we can approach DOE. I believe the Microsoft Azure resource also supports HIPAA data as well. It will say on each one of them. And one thing we want to do is make a tag so you can find.
That also then that some assurances for say our IVs the assurance platform through theirs as
Right. There's the platforms that are certified will have that certification, but the end user is going to have to work with that resource. So, I mean, we're not at a stage. The full NAIR would be envisioned to have this more. But right now, it would be kind of discussions with each of those potential resource providers.
I wonder, after this 2 year pilot, what's the vision for the development forms on the activities on the issues, success or state run as otherwise or PI carbon waste that are what's the
Yeah, great question. And I had this slide in somewhere, but look it out. So the vision for the NAIR is that there is a non-governmental operating entity. Think of a competed entity that operates the NAIR on a day-to-day basis. The NAIR task force report articulates that or envisions that to be a $60 to $70 million funded entity. Okay. And then different resources are integrated, and that integration is managed by that operating. And so actually the bulk of the envisioned funding for the NAIR goes to different resource providers. So the operating entity itself may not be providing that many of those resources, but those are integrated and contributed from different agencies. Perhaps your question is, well, where does that funding come from? I mean, ultimately, to grow and scale the NAIR will take additional funding. I would say there is, you know, a lot of support on the Hill for this concept of the NAIR. I think it's viewed as a high priority, but you know, no one really can say until there is additional funding.
Oh, maybe it's not really as you were speaking, I'm hearing the plus of the nobody inside national council tends to budget for national. We, University of Delaware, University of Delaware, work together. It's something that we think most focus on the soil. Every now and also University of Delaware just paying notice, accessing data science. Now, because we research during the summer our institution. Yeah, I say this only because when I went to challenge lecture, I discovered my notice to that we really need to all of us work together. If we want this country to remain competitive. So when you're talking, we all listen. The participation of very important as we're working together with by the institution. A complementary work needs always seen. And our students now, one is saying, they're coming to my office and say, are we going to have another project next summer?
You should tell them their pilot opportunity. But I will say, so we fully agree. I mean, our country has huge challenges, and we need the best minds from everywhere across our country, and we cannot afford to leave some communities not included in helping to solve these really critical problems for the country, right? Whether they're around the climate or the environment or you know, security of and our NSF director talks about, you know, our research is a national security issue, right? So we absolutely are, the vision for the NAIR is to reach communities across this country. And, you know, that is why we put out the NAIR pilot expansion opportunity. And so I would encourage you and everyone to look at those types of opportunities. Where can you build regional partnerships? Where can you come up with really creative solutions and opportunities? I'll say, you know, the NAIR pilot is also intended, I gotta get off the stage. The NAIR pilot is also intended when you request resources and emerging opportunities here to be pretty lightweight, so that request for access to resources, those computing and data resources, is a 3-page submission. It's not an NSF proposal. And so sometimes when I've gone to talk with smaller colleges, they say, oh, do I have to go through my sponsored research office? That's really hard, you know. They don't have a lot of staff. And the answer for those resource requests is no. And so, you know, we're getting a huge span of requests. When requests are on the smaller scale, I think, you know, the reviewers are really looking at, you know, are these researchers that, you know, haven't historically used NSF resources? Are they from new institutions? So I'm really encouraging people to apply for those resources. And then you still have to work on the funding resources, but get access to these really critical resources.
I just want to say that the top needs to share about project. A student went to there's some symposium. This research paper was just that funding has to go because no way out. Because of lack of resources. Because of proposal has to do that. And then we are through that proposal also leadership. You're also creating data science.
Great. Well, thank you all for having me here. Maybe, is there one more question?
Oh,
okay.
I wanted to ask about the flexibility of machines. A lot of us are, you know, like trying to use data servers and lab dealing, and they're often designed to kind of break computing records, do massive amounts of compute, but then we have to kind of shoehorn right into this. There's a lot of interesting energy in the UAMD processors, other processors, you know, kind of like threads. There's lots of proposals that, you know, we know that we can do it, but it requires a lot of work on the infrastructure side. It requires a lot of flexibility in design. I was wondering what was put into this, because you know, I have been struggling trying to get a big computing cluster to really actually do, you know, effectively use it, you know, to do large processing.
So I think what we're trying to do within OAC and the larger NAIR is a front door that the researchers can come into and then get matched to the appropriate resource. So I'd probably have to talk to you further, but I know kind of the ACES system, I think that's at Texas A&M, that is intended to be kind of a configurable system. There's the system at, you know, Indiana, which I know I'm in Illinois, but there's a system at Indiana that is sort of a cloud-based system that I think is kind of an example of a more configurable system. So I think there are some configurable systems in the portfolio. There's also some massive large systems, right, that come with an image already installed, and that's what you're gonna, you know, probably get. But maybe we can talk further about that.
Thank you. My name is Sanjay. And I have a question. The question is, how do we get collaboration? When we've done more, that many of these agencies have this program of enhancing those techniques or
Yeah, so you can to the if you Google like NSF NAIR, you can pull up the NSF page. It's not the NAIR pilot page that will show the contributions of every agency to the pilot. I mean, we're in a really lean pilot right now, and so NASA has contributed particular data sets. I think you're right in that many agencies have their own computing systems. What the NAIR is intended to build is this AI infrastructure so that every agency doesn't have to build their own. So there's not a mini NAIR for one agency or another, but there's a single clearinghouse and researchers that are funded by USDA or NSF or the VA can access those resources through a fund.
Maybe things you didn't think about in the pilot, maybe one or two, like, really didn't expect this.
Oh, I didn't expect any of them. I mean, I almost sort of tear up looking at some of the abstracts. They're so exciting. Maybe one thing that is coming in strong is the biomedical community is coming in actually very strong to the pilot. And so either NIH is getting the word out to their communities, or there's a real they have a big need there. Yeah.
Again. You're a scientist at Argonne National Laboratory, and he's going to tell us about the FAST initiative from the DOE side. Yeah, it's okay. Yeah, we're only a few minutes behind. It's just it goes up against the coffee break, and we can always take a little nap. Is this yours? Yeah, let me go. Right. This is. Yeah. I just need to share it. No, I know. First, let me share this. Oh, we just do this little. And I was just saying, and then we do display settings. Make sure we are. No, it doesn't display right on the Zoom. Unless do you need presenter view?
No, that's. Okay, thank you for undertaking to present FAST here at this conference. So I must say that I worked for 4 years at NCSA and University of Illinois, and so I'm very happy to come back for one day here. Only one day, but very precious. So yeah, today we'll talk about this initiative, which is pushed by DOE. So it's called FAST. It's Frontier AI for Science, Security, and Technology. So I'm Franck Capello from Argonne, and I lead the evaluation of another project that Argonne is developing, which is consistent with FAST. It's called Aurora GPT, and that's a large language model, a foundation model to accelerate research discovery. So that's essentially an AI research assistant that we are trying to build. But today I will talk about FAST. You will see some slide about Aurora GPT, but that's just to give examples of what could be done in FAST. So all the topics that I will cover today, they are coming from your presentation that Rick Stevens has done already. Rick is from Argonne, Associate Lab Director, is pushing this initiative, so Frontier AI for Science, Security, and Technology. So he's really the man behind all of these efforts. So the first thing to understand is why DOE is interested in doing FAST and why now. And you will see several motivations, several observations that have been done recently, justifying the fact that we want to invest a lot of money in doing this project. We don't have the money yet, so I want to clarify that immediately, right? It's in discussion at Congress, so that's where it is. But we really hope to be able to do this project. And so the first thing, of course, is the first observation is that there is a lot of interest from the scientific community academia, in fact, in using AI in different aspects of the research. So this is a paper that has been published by Ian Foster and some of his colleagues about looking at the papers that have been published in the past and how many times AI is used in these papers. This is coming from a directory here, which is Semantic Scholar Academic Graph. And so you see the uptake from 2015. You don't see the uptake of what's coming after 2022, which is really where the large language model became available, right? So obviously this will be even more sharp line after that. The important aspect of this is also that it's not just for one science; it's really covering many topics. Almost all of the science in academia are looking at using AI in one form or another. So that's very important to justify the fact that we need funding for a large diversity of science research. The second observation, and that's more recent, is that in fact the science committee has identified a research direction. And this has been done through several meetings, several workshops, several reports that have been published. So some by DOE, you see the two reports here that have been produced by DOE in 2019, 2022. But you could look you can look at the National Academy. There is a report. You can look at some report with NSF that have been published in 2022. You can look at Europe or even OECD, and there are some direction that are presented here. I mean, in these reports about what we should do. A very important aspect in this identification is the notion that compared to what industry is doing, ChatGPT and others, really the data that we are using, I mean, our research is based on multimodal data. And these are data that have many different representations and which are not necessarily the one that the industry is looking at. And so this is a very fundamental aspect for what we want to do. If we want to train large language model, foundation model, for a large set of applications, we need to understand and to use multimodal data. And this is really critical to enable the rest, which is the research directions. So for example, you see for discovery, how you will use this multimodal data and train models in order to discover new battery mechanisms, new chemistry, new drugs. How with this multimodal data, you will be able to control accelerators, to control reactors and experiments. How with this data, in fact, you will augment simulation. So for example, surrogate model that we are really considering to accelerate the computations, that they need a lot of data to be able to, for their training. We also need a better understanding from the model about the science and the math. You know that some of these models, many of them, in fact, are struggling in terms of reasoning. And so this notion of bringing more scientific data, more data about reasoning also will help to increase this notion of comprehension by the model about the physics and the mathematics. Of course, the notion of generative model is important, again, to accelerate cosmology simulations, for example, because it's generating a lot of data, but it's also consuming a lot of resources. So if we can use generative model to produce data without having to simulate everything, that would be great. Inverse problem solving is also something of very important interest for the research community. So if you look at that, really the multimodal data and the understanding of how to use it and to transform it in order to train the model is critical. So these are the different topics that DOE has considered as important for the science community that we are serving. So again, inverse design, autonomous discovery, development of surrogate model with a target which is zeta scale. Zeta scale cannot be done with just the increase of the technology, the improvement of the technology. We really need to have some acceleration coming from the algorithmic, and then using surrogate model is one path toward this objective. There is also, as you may imagine, a lot of efforts at DOE, but probably elsewhere, in order to develop mechanism to program, to generate codes. We have at DOE millions of lines of Fortran code. We really want to translate these codes into some more modern programming languages, and using AI for that it would be a very important step in what we are doing. So control of complex systems, everything I've mentioned so far might be small. Here you see that we are also looking at controlling big accelerators or power grids, for example, on how we can control that using AI. The last rectangle here is very important to me. So that's the foundation model for scientific knowledge. That's what I call the research assistant, where in fact you will use an AI model, so a foundation model, for the different steps that you are going through when you are developing your research, and you hope that this model can help you to generate hypotheses and to go into these different steps to solve your problem. So the third observation is that there is an exceptional capability improvement in the past 6 years. In fact, if we just look at 2019, 2022, that's when the large language model came and became available. And so that was the first important aspect. The exascale machine also were supposed to happen. So some of them were installed at that time. Why this is important? Because if we have exascale machine, this means that we can train very large models. We really need extreme scale machine to train model. If we don't have them, we cannot use this very large or train this very large model. And the other thing that has been observed during that time is the explosion of new AI hardware. So you have seen all these startups that are proposing AI accelerators. And so that's also something to consider. So a very important and sharp improvement of the capabilities, which has even accelerated more recently in the past 2 years. And a very important aspect, which is that the foundation model or large language model become provided by the open community, become competitive compared to the commercial models. So Llama, for example, Llama 3 for 105 billion parameters is competitive against ChatGPT. So that's where, in fact, it's an important point for us, because then we can imagine using Llama, training Llama with our science data in order to develop models that will be competitive and do perform better than the one that the industry is using, because industry is not necessarily training on scientific data. So another aspect which is important is that we are starting to see the emergence of benchmarks specifically for science to test these models. And I must say that these benchmarks, after a long exploration, they are not good enough for what we want to do. And so at Argonne, we are developing some specific benchmarks for science applications, very rigorous approach in order to be able to trust the model. Because if you are using model for science, right, you really need to trust what the model will generate. And this notion of evaluation is extremely important. And the fourth observation, I think, is in the context here, is that the science committee has the needed data. So we have the data to train these models to do science. And it's not necessarily true for the companies. So they can access maybe some part of this data, but they may not be interested, in fact, in trying to do cosmology research. Right? But we have the data, and if we have the model and the machine, we can do research using AI and large language model or foundation model for that. But there are many other data sets here. It's just a very simple presentation. So what is FAST? So this FAST has been announced, in fact, by DOE. This has been done in May 8th this year. This was at the AI Expo for National Competitiveness in Washington. And the idea here is really to push this project. And again, it's not funded yet, but there is a push in order to be able to get the money and start working on this project. So the main, if you look at FAST, in fact, you can see that there is a presentation, a short flyers that you can look at. And what this flyer says is that the idea is to solidify the US leadership in safe and trustworthy artificial intelligence systems for scientific discovery, energy research, and national security. So it's not only about research, it's also about security. That's why there is some connection with NNSA and to push this project. So the goal and the outcome, so the idea is to make sure that US with DOE lead in technical capabilities for the mission, for its mission in science, in energy and national security, that we can create, deploy, and sustain world-leading frontier AI systems and applications, that in fact we can increase the productivity and the capability of the DOE laboratories, academic agencies, and international partners, and that we can develop an AI-forward workforce. So that's a very important aspect. If we are going to do this project, we need a lot of people, and that's one of the important requirements for this project, to have this number of people. So this is for science discovery in science, for engineering and energy transition, sorry, and for national security. So this is the cartoon. This is essentially what FAST is about. So you have an aspect of data, which was discussed today and yesterday. So one aspect is collecting this data and transforming this data. I will talk more about that. Then there is the compute. If we want to serve a very large community, we need a lot of compute, much more than what we have today. So this is beyond the Exascale system that have been installed. We need to do research on models, so AI models, in particular foundation models, not only using the ones that are available in the community, but also maybe optimizing and developing connection between these models and other tools like theorem provers, for example, or numerical libraries, right? So how we do this connection. And there is also models for national security. I will not talk about that today, but that's not only for science, this is also for national security. These are supposed to be foundation models that will be fine-tuned for multiple different applications. So you see the applications here. So scientific discovery, digital twin, inverse design. I mean, these different applications are the target of the FAST project. So if we look at the scope and the effort needed in terms of resources, it's like one order of magnitude or more than ECP. So if you remember, ECP is the Exascale computing project. So there was a project that lasted 7 years and which created, in fact, these 2 Exascale machines that we have at DOE with the software that was developed for these machines. And so what we are looking at here is something which is at least one order of magnitude bigger than the ECP project. So there are, as I said, 4 pillars, and this is the flyers that you can get from DOE that explains, in fact, these initiatives. And so the first pillar, which is the data, is really to understand how we transform this repository that we have at DOE, but also some external repository, how we transform that into data that could be ingested into the model. And that's really not trivial to do that. I will explain some of it. Then the platform aspect, the second pillar, is really to build the next generation of energy efficient AI-enabled supercomputer. And I would say they're really focusing on the AI training and AI inference. The third pillar is really about the model themselves and how we use the data that we will have collected and transformed in order to learn, to make the model learn about physics, about mathematics, and biology. So that's really an important aspect. It's again, we are working in the ORA-GPT project in that direction, and it's not necessarily, of course, trivial to do that. So there is a lot of effort in that direction that's needed. And the last pillar is this AI application. So how we fine-tune to cover the different application using the expertise of the researcher who will be the users of these applications. So the key point, data, we are looking at 1,000 trillion tokens. So if you consider a token between 1 and 8 bytes, we are considering petabytes of data for the training of these AI models. In terms of platform, we are considering about 1,000 AI exaflops. So this means not the real 64-bit exaflop, but more 8-bit floating point numbers. And so we are considering not only one machine, but maybe multiple machines for training and multiple machines for inference. The idea for the foundation model is not to train a big, could be a big, unique foundation model, but there are more directions like, for example, training different foundation models for the different application domains. So that's why you see here training in order of dozens of foundations model to cover the different science, energy, and security, national security aspect. And then the applications, so that's the fine tuning. And we hope to you'll be able to fine tune for hundreds or thousands of different use cases. So you have some numbers here in terms of money. So data, you're about 700 million a year, platform 1 billion a year, model 500 million a year, and application 200 million a year. So that's a project which is at the scale of $10 billion over 5 years. So that's a lot of money. And as I said, it will require a lot of people to work on this project. So one aspect that we have observed when we have started and when we are doing our GPT is the problem of coordination between all the teams that are involved in developing foundation model or fine-tuning them and collecting the data. This is really something that needs to be coordinated carefully to be able to train the model. You need the data to be adapted. And this means that you need to produce the tokens in the time. And as you will see, producing token is not trivial from the science data. The application needs to be deployed with the existing model. And then this application will need to use the new model as they become available. So this means that there's some kind of iterative tuning of these models. We should not wait for the final model to be ready. The application should start using that to do some evaluation and give some feedback to understand how we can improve the model themselves. And so we need significant resources to train these foundation models, and we don't want to cannibalize the HPC resources. So even though we have Aurora at Argonne, so which is the exascale system, we don't want to use it only for training big AI models. But so training is one thing. Inference is also very important because if you serve a very large community of researchers, you need to be able to serve quickly the response. To these users, you need between 50 and 100 GPUs to accommodate one inference. And of course, you can block the request to maximize the use of the GPU. But at the end of the day, this is still requiring a lot of resources. So inference is not as trivial as we may imagine. And as I said, we need to increase the staff, and we are thinking that the project itself will need something like 2,000 FTEs to be completed. So you see here the challenge of pre-training. So we know that because we are training models at large scale at Argonne. And so you see the training token versus model parameters. And you see these models, the Llama models that have been trained by Meta, where they fit in this space. If we just want to train for 1 month on an exascale system like Aurora, we have green area that we should consider, right? So we cannot, if we really want to train a trillion parameter model, that will require more than 1 year on a system like Aurora. And so that's why we need other machines specialized for AI training and AI inference after that to develop these models. So these are the data size or the tokens that we need for the different application. I will not go into the detail here, but we need to collect and transform a very large variety of data. So let's look at the challenge corresponding to the data. So again, these are all scientific data with multimodal aspects. I can talk about the experience that we have at Argonne. So we are developing our GPT, which is a foundation model that is working as an AI research assistant, trying to help you to solve your problem and to speed up scientific discovery. And the experience that we have is this one, is really to try to collect, transform 10 trillion tokens of general text and 10 to 20 trillion tokens of domain-specific scientific data to train the model. And what we have observed is, if you look, yes, the data needs to be multimodal. That's very important. You need to be able to transform the scientific data into tokens that could be used for training, and that's not trivial. So we use a certain mechanism for that. If you're interested, I can talk about it. But the main problem that we are facing, or that everyone is facing when training a very large model, is this notion of deduplication of the data and avoiding contamination between the training set and the evaluation set. And so we have to work on transforming the data. So there is a workflow that has been established for data preparation, and there is a workflow also that has been established for the evaluation, and all of that require significant effort. So some of the things that we have observed, and you may face, if you want to train model with, for example, chemistry or material science data, you will have, if you want to train a foundation model, you will have this type of data. So some of them are very explicit. You can see exactly what it is that this material is, but then in some directory, you have material classified just by number. And that doesn't help us to train this model. Another aspect is the cosmology. So if you want to train this model using cosmology data, you are facing with this problem, which is the size of the data that's been generated. So one simulation of the HAC cosmology simulation will generate petabytes. Do we really need all this data to train the model? What is the information that the user actually needs in the model in order to do its science? So that's a really important question. So how do we filter the data? And then there is the notion of persona, which is kind of contradicting what I just said. Reducing the data is good, but then you may need to serve different communities. And these communities may have different interests in the data. And so you need to consider all of that when you do this data analysis and reduction. The other aspect that I want to mention is deduplication. One problem in this large language model is the memorization and the lack of generality if you have duplicated data, right? So if you have duplicated data, you have a big risk of having a model which overfits this data and will not generalize. And there have been papers that have been showing that. So the problem that we have is that we need to deduplicate a very large set of scientific data in order to train these models. And the deduplication is not only about textual, it's only about the semantic of this data. So again, the information that this data is carrying. So I will just mention one thing, is that evaluation is critical. So I talk about the model, I talk about the machine, I talk about the data, but at the end of the day, the only way to trust these models is to do the evaluation and to have a very rigorous evaluation. Otherwise, we will not trust them as assistants for help for our research. And so there is an effort at Argonne, I will not explain that, to look at not only the skills, of course, of these models, so make sure that they have the right skills and they generate the right result for us, but also looking at their safety. And this is a very important aspect. There have been many policies that have been published by the industry or by the government. This notion of safety is paramount. We will use this model only if they are safe for us, but also if they cannot generate harmful for others, harmful problems for others. I will skip about that, but I wanted to just conclude that FAST is a very big initiative to cover energy research, science, and national security. I mentioned the four main pillars of it, and the two main challenges that we think we are facing, so scientific data collection, preparation, and for training and the evaluation. And again, I will not stress enough that evaluation is really the key in this problem. You need to have a very strong evaluation. And that's it. Thank you.
Thank you.
I think it's a great talk. Many of us are writing papers on developing pre-treatment strategies.
Yeah.
And a lot of the things that we developed in language scientific is that the strategy and the way you embed the data. Focus. And I wouldn't say by any means there's a clear picture of how we can do this. But it seems the way you presented this is that the kind of training strategies, kind of ideas already there. We should just go ahead and run. But I feel like you know, a lot of the models training are not like this, like much smaller.
Yes.
That's right.
Yes.
So I wonder how you integrate this kind of R&D model integration before we scale up things.
Yeah. So, okay, I'm
just
sorry.
so much of how those happen.
Yeah. So I'm sorry if I was not clear on that. I mean, FAST is not just the production of the models, assuming that we have everything in place and we know how to train this model. This is how we train this model. What model we choose, what parameter, I mean, hyperparameter we choose, all of that is part of FAST, is how we make these models, right? It's not only the production of the model for usage for science, it's really also how we understand these models, right? So this is research and the research that you are mentioning, which is behind. But so we have started with our GPT to look at this problem, and since really it's we have trained multiple models, look at different mechanisms to train them, different parameterization. And so this is a real important effort, as you said. It's really important to do that. And so I'm not excluding that from FAST. It will be part of it.
Very interesting topic. I can see the huge potential in large language model for discovery by research application. So in terms of the raw data, so I have a question related to how to get data from all these papers. Most of them are copyright.
Yes.
So that's the first side of the question. Second, to truly understand SCU, you need data agreement and all that. You can scan the tons of papers.
Yes.
But the papers are complicated. It's images,
yes.
charts.
Yes.
So what is the understand not only the text, but also the pictures and all that?
So we have so the first part of the question was what?
About copyright.
Yeah, copyright. So yeah, so just to give you an example, to train our GPT, I contacted the ACM, and we got from the ACM the full digital library to train the model. That was fine. Of course, we cannot show this library. It's very well protected, right? But we can train the model. I asked the same question to IEEE, and IEEE doesn't want that. Right? So there is a problem of copyright. We need to discuss and enter in negotiation with them in order to get access to that. I had some discussion with some people at Elsevier, and it seems that we can also get access to that. So I didn't show in this presentation the data set that we already have, how many papers we already have, but you have many. We already have many. So the goal is to be at the 100 millions of paper, right? And if you look at where we are now, we are not close, but we are getting there. So that's the for the copyright aspect. The other thing that you were mentioning is that your paper by itself is multimodal. It's not just text. You have figure, you have equations and all of that. So we have a team at Argonne which is dedicated to make these transformations of the papers into something that we can inject into the model. So I cannot give details here, but I will refer you to contact this team to really look at the tools they are using.
Thank you for the my question. So the question is about we all know that reproducibility is sciences and AI. When you talk about AI for science, how do you think about this challenge? Whether it will make it worsen, or will AI for science will different? So, and what is this initiative doing about?
So of course, reproducibility is the core aspect of research. I come with some electronic and physics training, so you know, reproducibility is really something important. In the past, what I did was to develop an environment to make experiment on parallel and distributed computing reproducible. So I'm really looking at this aspect. What we are doing, and we are considering this problem of reproducibility in the context of AI, in this context that I just mentioned, right? So if you use an AI assistant or an AI accelerator for your simulations, you need to have some form of reproducibility. So we have some research on UQ, so how you can use uncertainty quantifications in order to see the deviations that you may have for multiple response of the same question, or some slight variation of the question, slight variation of the input. So we have some research and some development on this aspect. So reproducibility is really important. How AI can help reproducibility, that I don't know. I mean, we are not looking at that. I am not looking at that.
Two more questions. The next question.
Go ahead.
The slide was it's trustworthy AI. And within the text box, it says we're going to build, we're going to scale, we build large systems, see what emerges. That's our approach to determining trust. There's a little more detail about reading and seeing what emerges.
So trust is covering many different aspects of this AI system. So what you see here is one benchmark has been developed at the University of Chicago. It's called Decoding Trust. And the idea here is to see if these models can be helpful to you. They have biases. Can they go into some direction that hurts you, right? So that's one of the aspects of you're trusting the model that it will not, it will be safe. The second aspect is this benchmark that has been published also recently. It's called the weapon of mass destruction proxy, and the idea is to make sure that the model will not be able to generate harmful weapons, right? So chemicals or whatever. So for that, you need to understand what are the skills that are needed in this model to generate, potentially generate these harmful weapons, and then try to see how you can remove this, some of the models. So that's trusting from the perspective of safety and security, right? But you also, as a researcher, you want to trust the model. And why you want to trust the model? Because what we are doing now, and I can show you some experiment that we did recently. Yes, for example, for this one. So what we do here is that we use existing LLM and we try to solve a problem, an existing problem which is open. For example, in that case, this is to try to simulate the shock that happens on wing when it goes supersonic. So we want to do that, and what you need to do is to solve a PDE which is nonlinear. We try to use the existing models and we compare them, all the existing models, and we compare them to see how good they are, right? And if you can trust or not some of their aspects. And you can see here the evaluation that we have done. You can use some evaluation criteria to see if you can really trust the model. So far, you cannot really trust this model, except for some very specific aspects, right? So as a researcher, if I want to use this model, I need to develop mechanisms for the evaluation that will make sure that, in fact, we stress the model in such a way that we can trust its results. Right? But really, trustworthiness is a very important aspect, and it needs to be done through evaluation.
Right. Hi, very good talk. And I wonder this Aurora GPT has been put on archival.
No.
No? Okay.
No, so we started our GPT like 9 months ago. It's an effort with 30 persons. There are 8 teams working on the different aspects. I mentioned the coordination in data model engineering, post-training, and evaluation. You need coordination. So we will publish the model when it will be trained. We have multiple generations of models. So the first model will be probably an AB model, probably, with science data. Right? So that's our first goal is to produce a model trained on science data based on Llama-3 8B. So that's what we will do. We will probably publish at that point the model and the paper corresponding to the model. That I will not expect that before the end of the year.
Okay. So do you plan to upload, make it open source like
Yes. Yes.
everyone else?
Everything will be open. But again, if the model itself trained on scientific data is harmful or not, and so we need to make sure first that we run our own tests, of trustworthiness, and if it passes the test, then we will make it public, and to improve.
I also wonder what is the largest pre-training data set, how large your pre-training data set is, and what is the largest pre-training model you have used?
For what? I mean, for FAST, I mentioned the size of the data set that we need, like 1,000 trillion token. For our GPT is 10 to 20 trillion tokens that we need for the training.
Okay, thank you. So another question is regarding the computing resources. So you work in DOE, right? I wonder, like as you know, retraining these large foundation models is costly.
Yeah.
Well, not many institutions have access to such large
Exactly.
GPU computing resource. Well, I wonder whether there's a DOE office can support this external demand for building the large foundation models.
Well, that's what FAST is trying to do.
Okay.
The FAST project is trying to get money in order to buy big machines. I mean, that's one part of it. To buy big machines to be able to train the very large models. And this will open to the community probably through the inside mechanism that we have at the OE.
Thank you.
Yeah.
Thank you. You know, coffee break is right here, and we'll extend the coffee break by 5 minutes. So we'll actually come 15-minute coffee break. We'll come back at 10 out, and we'll hear the visitor chat stop. So at 10:50, come back into the room.
Some department. And sort of, let's see, we actually have a. All right, we have a talk now. I mean, it's gonna be blocking, so. Um, I actually know. Okay. I read yesterday. Oh, okay, I was. Oh, you're coming to see. Yeah, good. And it's the first day of the winter. I'm gonna put it right on.
Okay.
I can't believe it. Well, I guess I.
It's
I know, I've done it for.
Yeah, yeah.
I mean. Was it in your?
Yeah.
Hello. Yeah. Okay. I can put it on the, I can link it to the panel session. If it's a Google, just send me the Google link, the shareable link. Make sure you do view, link by link sharing and view. Hi there, how are you doing, Jonah? No problem. Well, thanks for your help on the committee. I know. Yes. Sorry. Lots of emails, but no, it's going well. And yeah, your deputy did a great job presenting the institute. So, so we're good. Yeah. Oh, you just arrived this morning. Okay. Did you happen to see the talks, the Katie's talk this morning and the fast talk, or you just got here now? Okay, the recordings are here, yeah, so we can watch them. Anyway, thanks. Okay. Are you going to the dinner tonight? Or do you have other things to? Oh, we have a conference dinner at, actually I'm doing Blue Water tour and then we have a conference, 6 o'clock. It's yeah, right now, yeah, right next door to here. In the same building, just on the other side of the partition. Yeah, come by, please, yeah. And you even have a drink ticket, I think you have. Come by, yeah. Okay, see ya. Oh, the. and said they were happy to walk.
Yeah.
Is that a high ticketing area at the end?
I've heard people, it is.
Oh, sure.
Yeah, very good.
Okay. Okay, let's start. Let's get started. If you're near the door, if you could help your colleagues get in and get settled. Okay, let me make a quick announcement. So if you want to, we are doing a tour of the National Petascale Computing Facility. You've seen an email from me on this probably if you're registered. We would benefit greatly from a count. And so they're limited to 50, but we're going to be below 50 for both, so it should be okay. But the organizers, the tour people who run the tour would really benefit from a count. They have access to this Google Doc. So there's a Google Forms. Please sign up if you want. There's one today, right before the conference dinner at 5 p.m. Conference dinner. There's another one that's scheduled for 1 p.m. So if you want to take a tour, please fill out the Google form. These slides are also available on the Indigo page. Right now, 36 people have signed up for today's and a few people for Thursdays. And then the second announcement I wanted to make, and I assume there's no minimum, right? If we had 6-8 people, they'd still do a tour. Okay. The other thing I wanted to mention is you're creating memories. This is a little dramatic here. You're creating memories. Please help us to preserve and share them. Okay, so I've seen many of you taking pictures. There's some really kind of cool, novel little things like me driving the shuttle. Somebody took a picture of me driving, which is kind of hilarious. So anyway, if you have pictures, there's a Google Drive folder. Please put your pictures there. Show them on the conference site. Okay, let's start now with our presentation. Let me just right here. Okay, I have no idea where anything went, but okay. Oh, there we go. It's like, okay, so hide floating meeting controls. And then let's just go. All right. It's my pleasure to introduce Dr. Jerry and also the co-lead of the AMD Excellence. Right here. And also Illinois IBM, which is a fantastic partnership with Illinois and IBM. So he is going, and he's also a close colleague. He's somebody who is my co-PI at Illinois on the one of the 5 HDR institutes. He's an expert in accelerated AI and FPGAs. And he's going to talk about knowledge transfer and AI workload acceleration from academia to industry. Okay, so thank you.
Thank you, Mark, for the very nice introduction. Right, so let's get to it. So very strong ongoing collaboration between academia and industry at UIUC, right? So this is definitely an incomplete list, right? And in terms of large industry sponsor centers, institutes, IIDAI, right? Mark just mentioned it. right? C9, so this is for the center here. And then we also have other technical centers, Hamel is EP, this is the environment, the infrastructure, then there are industry members, right, who get together, right, to really push forward in terms of technology, in terms of research, and right, so there's a naturally interaction, right, across the researchers, you know, in the university and in the industry. Okay, so in the same time, we also have smaller and medium-sized partnerships. So MD Center of right, and then also Amazon Illinois Center, various other have these kind of collaborations or have been working kind of partnerships. Okay, so today we'll mainly focus on IDAI and the decentralized. It's true. Okay, so a quick introduction of IDI, IBM Illinois Discovery Accelerator Institute. It's a new model of academic industry partnership. And then you see this accelerator, and I think we all love acceleration. Okay, and then this is not just about AI acceleration, although it's part of it, right? It's about discovery, it's about scientific discovery, right? So physicists or biologists, right? So these are very, very relevant. Okay, and it's established 3 years ago, and with annual support of 7 million. Okay, and but then there's college, state, matching fund, right? So in terms of research, we have mainly hybrid cloud and AI, and quantum computing, materials discovery, sustainability. I will highlight that from hybrid cloud and AI because I work on, you know, so I started to learn quantum computing, but still quite beyond me. Okay, all right. So, in terms of the kind of structure, right, in the first 3 years, you know, it has been co-led by David Cahill, of you know him, right? And the IBM director is Debbie Sao, right? And then starting October 15th, I will start become the Illinois director, and I, you know, co-lead the institute with Fabio from IBM, and both of us work on computing systems, cloud computing, AI, etc. Right. So far, this institute has 90 faculty, 150 graduate students, and with us. And we have publications, and then so-called we all internship, the industry, right? So this, the format is same. That's why they can continue to work on their research, right? And then for the next years, right, so our hope is to support the future of computing built from most advanced technologies and to advance the needs of future AI and into individual kind of technologies, and but then let's try to understand, right? First of all, what is hybrid cloud? Okay. So it's a combination of private cloud and public. And the goal is trying to have public cloud economy and scalability while maintaining private cloud level security and privacy. Right. So here, if we look at the overall structure, right, we can partition it into 3 layers, right? Top layer, right? So here are some projects that we have worked on, right? Ranging from data understanding, right, to enabling cloud native HPC application, etc., right? And to right on the edge. And then in terms of middle layer, right? So this the infrastructure will be dealing with scheduling, you know, resource management, right? And then on the bottom, hardware layer, right? And so here, power hardware system co-design, right? And accelerator for irregular computation, you know, some
highlights of this project. And then of course, layer of projects, right? So for example, we have this cross-layer AI-driven resilience and right. So AI-driven control, right? AI-driven discovery, AI-driven language translation. We never thought for this, right? So somehow, right, we think a lot. Okay. All right. So here is one example, and we call it the I2 Cloud, right? And you can think it actually means IBM. Okay. So then you can see, this is more fine-grained partitioning, and some of you probably heard about Clouder. Clouder from NCSA, okay, and but then through this stack, right, through collaboration between Illinois and IBM, right, Illinois Clouder working with IBM CodeFlyer, right, and then in terms of infrastructure, you can of the key technology, right? OpenShift, right? And then software-defined infrastructure, etc. Okay, and then just very quickly from each individual project, right? So I do not have time to go into all the details, but this is quite interesting, right? This is a robot gate, right? And from Nancy Amato of computer science robot. You have the local robot sensing, and then even load the data to the cloud and do kind of digital twin kind of simulation and back and forth, right? And then the next, this is AI for code, okay? And we also right? This is a so-called code net, okay? And then IBM really took the lead on this. 14 million code samples, 500 million lines of code. This can really enable us to do code translation, code generation. And I don't worry, you actually this theory is consistent. Right? We have no intention to. All right. So then the next one is a cross-layer AI-driven, right? So I mentioned this at the beginning, right? 3 pillars and right, and then you can see on the right this graph, this learning agent that can really deal with the different kind of component of the system, right? And our overall goal is for resilience and security, and also target performance, right? And then this is about federated learning, right? And it's also very interesting. We all know a lot of times to the cloud, right? There might be privacy concerns and others. So all the training are local, right? And they are done by different clients. So how do you select them? And after you select them, and they need to be synchronized. Some are more powerful, some are less powerful, right? How do you very energy efficient? Right? Project we have, and through this very close collaboration between the industry and academia, so then we can students can learn the real challenges, and then from the industry point of view, they can work with us trying to achieve some long. Okay, so then this is highlight IBM Illinois Institute, right? So you can see this is even involving smart NIC card, right? Smart NIC card and scalable controllers. And then I highlighted we all happened together, and then faculty and students for externship. Okay, so let me quickly move on, right? So this quick introduction on AMD Center of Excellence, right? The center will investigate proposed system solutions for HPC, distributed computing, machine learning, etc. Right? And then, yeah, it's a and we will use IPGA's GPUs from right? He talked about one of the projects trying to using AMD GPU with AMD GPUs for a while. Right? So the goal is to create new opportunities
in data center as IPC domains, etc. Right, and they introduce them. All welcome to follow up with me and the students. Okay, and in terms of research threats, we have 4 threats: compilers and languages, system solutions, distributed computing network and storage, application and algorithm acceleration, etc. And then the second part of this effort is so-called HACC, right? So this is a heterogeneous accelerated computer cluster, right? Actually, the UIUC is 1 of 5. Okay, so then let's look at these 2 clusters at UIUC, right? And on the top, that's the Beckman Institute. And then, my office is at CSL, right? So the first cluster of the CSL. And then the second cluster that established very recently, right? And it's at the so-called CSL studio. Cluster, right? So this is established about 3 years ago, right? And then you can see there are about 4 compute nodes, right, with IPGAs like U250, U280, right? And then we have some GPU, right? And then it's VM and based and using the scheduler and so far 55 participating universities and about more than 100. And then for the second cluster, that's very recently established with some new donations from AMD, right? Then you can see here the AMD to leverage this AMD GPUs powerful, and it's easy. Actually, you can write CUDA code, and then they have tool to translate it to be run on top of AMD GPU. Okay, and then we also start to adopt this is a Kubernetes scheduling, right? We leverage this queue scheduler, which is actually so then also some quick highlights, right? So this one is a PyTorch 2 AI accelerator compiler, right? So some of you know about Scale HRS. Actually, Greg, one of the clusters is in tomorrow. And then for the first time, we can, because of this new flow we built, we can take PyTorch, models, right? All right, 1 minute left. I'm almost done. And then produce a synthesizable C code. And then we all love HelloSynthesis. We call downstreaming or synthesis tool and produce the accelerator. And it's a completely open source. So for a lot of downloads, feel free to check it out. And then we also did like a tutorial about this enable data streaming. If we can do data streaming, then I really sign up and start. We need to sign up that user stream. Okay. So then this second one I want to highlight, right, through collaboration with Professor Wenmei Hu, right, this Python code to pull MBCA. I really love Python. So this is really inspired by that. And then, for example, team also in the audience, together working with Vladimir, right? So trying to combine answer codes, transfer now and Python to our community. Okay. So this last slide, AMD UIUC, we also working on education, and we developed an open source IPGA board that you can really imagine writing on a board, right? So, and then we basically use this board to teach undergrad. And then train them. And then the good thing is we open source the teaching material on the board and start to really benefit the overall community. So in conclusion, I would say UIUC is actually a technical, okay? And then we have a rich and strong collaboration, and we plan to continue to do so, right? And then through such a collaboration, right, of course, we Okay, but then we also try to transfer the valuable knowledge back to the industry, and the research activity in the centers are aligned, right, with the strategic goals of industry. But then they are high-tech companies, so that they really value research, right? And many of the research projects are also open source, so that AI algorithm acceleration becoming increasingly important, right? So really moving forward, and let's build an excellent ecosystem for research, technology, and education. Thank you.
Other questions?
Thank you for the. I was just wondering how we can.
All right, so it's, you know, email. Can help you to set up solution. And then because each user we actually will get a UID. It's to be diversified, but everybody is equal. Yeah.
Thank you. The second.
Okay, so you're now at the panel. Panelist, thank you. You're a panelist. Can you? Despite your coloring, there's nothing special about it. Maybe it's a little more comfy. Let me bring up your slide.
Hey, Mark, it's Julia. Can you hear me?
Oh, yeah. Oh, sorry. Was there a question on Zoom?
Hi. No, I just wanted to let you know the audio coming from the room to Zoom is very intermittent.
I've been told that
Okay.
the microphone is too close to the speaker by our captioner. So is this a little bit better? I mean, is it better?
It's fine. It's fine when someone is speaking into the microphone, it seems, but if you turn your face away a bit, it really drops off. That's what
Yeah.
it seems to me.
Let me see.
So maybe for the panel, you'll have microphones or something up there, but
You me right now, right? Is this microphone pretty good?
that sounds good.
Okay, so that's for the panel. Okay.
Good morning, everyone. This panel, co-hosting, and the panel. We have 5 panelists here, but before I introduce the panel,
Can you introduce yourself? Julia, are you on? Okay, so list in the order, yes. But you might want to go ahead to go through one round, and then we'll open up.
And your trend, and formula.
I think this actually happens in our change of staff.
My name is George Percival. I got a project with that for a little while. Former CTO of the Geospatial Consortium. I now run the actual AI standards activities.
I'm John Bonner. I'm from the Texas Advanced Computing Center, and I serve as the director of the project. Years now. Background in the life sciences computing space, non-traditional agencies. At Tech, we're always doing different things with these systems. We have a lot of users from a lot of different areas. We onboard over 6,000 users a year. So I'm really happy to be part of this.
Previous life, I was a managed system. That's so on. I there were part of the explosive growth in demand for utility
Thanks. Thank you for all to all the panelists.
Hey,
I
Anand,
started off.
can I just
Yeah.
interrupt you? Yeah,
Yeah.
that mic is still, the audio is pretty tough still here in the Zoom room. I wonder, like it cuts in and out. I wonder if people just have to hold the mic really close. I don't know if that's possible, if there's another option.
Yeah.
Is this better online?
It seems like when you're close to this podium, it works well.
Okay.
When you walk away, it fades.
Okay. So Julia, are you still there? And do you want to introduce yourself as well?
Oh, sure. Yeah. Hi, everyone. My name is Julia. I am a scientist at Slack Lab out in California. I work in high energy collider physics and also on some machine learning and hardware for future detectors, which is the connection to some of the nice work happening in A3D3. And I'm one of the community engagement co-coordinators alongside Mark.
Thank you. Thank you. Yeah. So what we did was we came up with a list of. And I'll let the panelists choose whichever they want to discuss this question, whatever they want to talk about community engagement and how AI or data infrastructure community affects community engagement. next week. So we'll go here for maybe keep your comments. To 5 minutes. We'll see. We'll go from
Okay, so the second question I think is the one that really spoke out to me. So, yeah, so what are the challenges in making AI and advanced accessible for certain communities, and how can the HDR community ensure equal access to it? Thought a lot about this on the drive down. And I had kind of thought about this. I don't know if this is the right language, but what I call an indirect, what I call direct. So indirect is actually like put in that bucket is a lot of what like you heard from Anya and others earlier this morning. I think there's a lot of great initiatives. Not too much I have to add in terms of like education, right? Education of students, interns, general public, and other disciplines, just education of our sort of domains and things like that. And a couple of elements to it. So one is first education, also getting enthusiasm, and then for the science, people excited about positive. Arts rather than social science. And then bringing concrete challenges, data sets, and then the value that comes from this. Measurable metrics and that is a engagement. But the other one I'm talking about, which maybe not a lot of people think about, but sort of along this path in the last year, what I would call direct. So how do you directly engage with the community? And it's often challenging. Not present data, right? You have research to do, all these other things. And so one place I thought really interesting to do is otherwise is also like engaging with groups where it's day job to be. So a lot of SBR, profits, or things like that. So you're not reinventing the wheel, but working with those companies. So last year.
No, I think that's great. Yeah, yeah. Thank you so much. Yeah. Ashby.
Connected, so maybe I'll just put on something so I think that it's really critical to make sure that models are training on diverse data to start with. And that can be really challenging to do. So a lot of that work involves pursuing co-development approaches from the very beginning. So research was about the community involves our community, where it's going to ask how that community is being involved. So that can really help. Negative impacts and also unintended consequences. Being very intentional throughout the research process and meeting people where they are. I think this is one example that is kind of top of mind right now. So there's a research project that I'm involved in, NSF funded, and researchers Poland and Ukraine using AI-intensive methodologies to improve hydrogeologic modeling of this where on the ground measurement is just not possible right now. And so it's really important in partnerships that to go in and make sure that we're also more researchers from the US and researching a community that we don't live in. Funding is coming from the US. So does that mean in terms of language, do we adopt meetings in English? What's the loss coming to that? How do you mindfully work with partners who are in the horizon? And so I know that some of those maybe seem like small details, like language, how do we conduct meetings together, but small details, I think really do matter in that work, and it just takes more constant commitment into building genuine partnerships. And then also doing critical self-assessment throughout as researchers to make sure that we continuously improve those. Maybe kind of being up tying into some of the points in this. So conversations about democratizing access, structuring data, those aren't conversations, they've been happening for years, and there has been a lot of progress. There's still a lot of things not talk about. To talk about serving the long tail of each service that you have in the tail is arguably much better position to know some methodologies and some of these out. So we are really critical in defining so it's really all collectively grappling with how to navigate AI or to that we're doing is that we're serving those that are already using data computations and methodologies, where we're going to commit to bridging gaps that really allow position in scientific leadership areas beyond those that are currently. And the latter is, it's really challenging, especially when we consider the language gap between this piece and but not doing so. I think there are some missed opportunities. And, that's why we need more it's just going to take it's going to take innovative leadership from all of us, researchers, funders, professionals, our partners, to really make a difference in the roles that we have control over. And there are so many lessons learned from these HDR projects in the room, other NSF investments from the HDR era that really serve as a strong foundation.
Thank you.
Yeah, so community engagement. So let's talk about communities. Specifically, how does your research get into project products? What you're doing is fundamental research. And mentioned, sometimes it's better than some of the research inspires products. A particular perspective on how that transfer of the intellectual products that you develop happen is through the development stages. So think of IEEE, Wi-Fi, the internet, think of 33C, World Wide Web, and those kinds of standards bodies that are going to address what AI is. Governed by the federal government, the governments around the world, invoking standards about what products in Canada. So that's community perspective and the mechanisms. For the specific examples, then I'll talk about things in the past. I'm here for my guide. I'm a geographic guy. I'm a geospace guy. I'm a GIS. I think we're both sets of that. And so I think it's a longer space. And so how I see intellectual developments here influencing things around space and time. Historically, we've seen that with NSF projects. And Amy spoke yesterday a lot about what's been going on for a few years. I know and reaching back in the development of NSF developments,
particular, and iGuide and the like, have created the standards that are used for how GIS and other geospatial queries happen in the software that runs today. So it's based upon topological math research that was done 20 years ago, and now runs in every SQL box that runs spatial queries. It's those kinds of relationships that came, those kinds of intellectual property that came out of that NSF research 20 years ago now runs the geographic engines around the globe. So if we look now, you know, where are we sitting now and looking forward with the AI perspective as we go forward? What are the possibilities of the research that you're doing that could influence standards moving forward, in particular in space and time? So space, you know, some examples, the A3D3 guac high D semantic search to me is a really good example of how the spatial concepts have changed given the computing tools that we have for high dimensional AI research and the like. So that's a key one. We're able to do semantic search in very high dimensional space we're never able to do before. How do you do that? What are the metrics? Those are the kinds of things that are being considered for standards. Within iGuide, the telecoupling approach, which is essentially graph networks, so a different representation of space using graphs is a key aspect. How do you standardize the exchange of graph information? How do you establish metrics on graph, given that they're going to be interpreted by AI engines? The last example in the space category, the KGML stuff that we saw yesterday, and in particular, the top line of a slide. I don't know if the gentleman that presented the keynotes here, probably not, but you all saw the, you know, a set of categories about how to represent knowledge going across the top of those. Those were like PDEs and graphs and also other types of models. How to generalize those structures of knowledge so that you can have a common interface across those knowledge types is going to be a key aspect of the interoperability of AI going forward. The spatial web project that I now work on is using category theory in order to develop that common interface. Let's see where it goes. I offer that if any of that sounds interesting to you. I didn't hear any of that, but if there's any category theorists in the room that want to talk about how to represent knowledge and a common interface, I'd love to talk to you. The other example of you know, where we go in the future regards time, and in particular agents, AI agents that have behavior. So much of what, especially GIS in the past, has been is static. It's been images. It's been things that are, you're not changing over time. You know, ImageNet became significant because it put semantic labels on static images. What we need to be able to do now is look at behaviors, look at videos of activities going on and be able to identify, semantically label those kinds of behavior. The imagenomics work with respect to the baboons and looking at videos and the traits, behavior traits is a good example of that. I hope to figure out how to involve that in the spatial web activities that we're doing around agent behavior identification and standardization. So I'll leave you with HDR is very critical. Been involved with it for a few years. Great to see the research results coming out. It's another 20 years of work in order to get the results that you have now embedded broadly across the products that make up the world that we live in. So that's community engagement for me.
That's great. Kind of going the other direction, George was talking about the future of our own research and how that will impact society and how to make that into products. I think kind of the stories that are freshest in my mind are some of the outreach opportunities that we've had toward high school students. So at TAC, there is a group called Expanding Pathways in Computing, and they are working with high school level teachers in schools to promote computer science programming in that space. And then there's another group at TAC, an education outreach and training group that has been doing these summer camps called Code at TAC. And we've just actually passed the 10-year mark on that. And that has been one of the most informative things I have seen as far as engaging the community in underrepresented, under-resourced groups who would not dream of you know, themselves going into science in this area or really understand what's possible. I think AI and the way that it has permeated culture in these large language models, these diffusion models like for images, which are the same models that are powering like protein folding, right? But just the societal diffusion of those creates an opportunity for interest. And in some ways, it also resets the clock on skill set. The skills that are being used to develop these models are very fresh, even though the science goes back decades. And it's a new opportunity for people to engage with that and learn it and not feel like they're very far behind. I think one of the big things that we've learned over the last decade is despite the technology piece, how important the human engagement is. We are in Austin and are able to be local to Austin. We've worked for the last 10 years with different schools in Austin that are in communities where there are a lot of first-time college students, future college students that would come out of those schools. And so by targeting them and providing summer camp opportunities, follow-up opportunities to do back at TAC where we re-engage with them and their families has been really powerful. And that has really started with relationships with people at those high schools. So that who's the college advisor at the school, or who is the principal, their head of school that would be interested in knowing about what we're doing and interested in helping us connect resources to the people who can most benefit from them in our community. And I will say there's no way that TAC could be effective outside of Austin, because it really is a truly human interaction. And it's an opportunity from whatever communities you represent to build those relationships. It takes time. And I know of success stories from SDSC as well, doing the same type of work. It takes time, but it's inherently local and it's inherently human. And this AI revolution actually has a neat opportunity for us.
All right. Well, I'm not sure the last seat's any better than the first, because there's not a lot left, right? But certainly all of these comments are very good. I don't want to forget the things that we all know and that maybe we should state. First of all, that there are a lot of resources that are available, both technologically and training wise. Certainly access has made getting time on systems almost trivial. So I assume anyone in the room should know that if you go to Access, you or your graduate student even can basically get an allocation on any of the Access allocated resources nationwide with basically a paragraph of information. So that is out there. There are lots of free training activities that all the resource providers throughout the nation, certainly NCSA, TAC, SDSC are all included in that. And we very much encourage you to take advantage of those as you can, or have your students do so. What John just mentioned is going further is how do you reach the people who aren't even looking? And that's really the challenge today, I think, is how to engage the folks that aren't even considering this sort of thing as a career path. And that's a big challenge nationwide. I think a lot of us are tackling that in similar ways to what have already been mentioned there. So a couple other comments about the data side of things. AI has made big waves with lots of the pre-trained data sets. One of the things that has been emphasized to me over time is that you really need to know your data set. How was it trained? Where did the data come from? If you don't, you really don't understand how good the results are going to be. There can be both legal and accuracy implications from those sorts of issues. So certainly if you don't know that the data that was used to train it was all free and open source, or at least licensed to be used in the training model, then it's probably not going to stand up to long-term use without legal challenges. So, and of course, if you don't understand what goes in it, you can't understand really how it's determining its results. As I'm old enough to know about semi-empirical methods back in chemistry, and that the issue was the same there. They were basically similar sorts of things back 30 years ago, 40 years ago, where you didn't really say that word trained, but you modeled and trained a model on a certain set of data and then used it to predict properties. The thing back then was if you exceeded, if your test was outside of that set of model data, you were going to get pretty dubious accuracy because it wasn't very good at extrapolating. And that's the same is true today with AI models. If you're well beyond the training data set with what you're asking, what your question is, you probably are going to get fairly dubious answers. So It's very important to understand how these things work and what the data, where the data comes from.
Thanks, Brett. Thank you to all the panelists for their initial comments. So first I want to open up to the audience to see if you have any questions to ask the panelists, and then we'll go from there.
Yeah, but I think if we're okay with 15 more minutes, then we eat a little lunch, but 15 minutes is fine, so let's have it.
Yeah.
Maybe just somebody wanna, any of these topics, the topics are incredibly compelling, so yeah.
So question 5 asks about interdisciplinary collaboration, and those who are directly named in that question are domain science experts, computational and data scientists, and sort of scientists in general. I'm interested in hearing how communities have impacted, so down up, into the science, and some direct examples of where you had to change a project because of that expertise. How have outside folks been able to inform the work that you do?
If you're asking a question, you want to direct it to a certain panelist, feel free, but if it's just general, then just somebody pick it up or multiple panelists.
Yeah, I can take a stab at that. So I think there is one very good example. So it involves, it's an NSF funded project, EarthCube, the EarthCube office, and its final phase was led out of SDSC by Christine Kirkpatrick. And there were a lot of challenges to navigate with that project if anyone is familiar with it. So it required collaborations between computer and data scientists and domain scientists. And the initial approach, it didn't work. Computer scientists, domain scientists, they came ready to prescribe cyber infrastructure solutions to domain scientists, and nobody showed up. And so instead, the project took a step back. I know that at a certain point, NSF, they had to shift, they had to fund workshops to really figure out what the translational piece was, how to better meet people where they were. And then the projects that came out of that project afterward were much more successful. So yeah, that I think is a good example of a project that involved two very different types of scientific approaches.
Thank you. Did that answer everything, or do you follow up? You're good.
Hi, Fernando Moro here at the University of New Mexico. So maybe it's a general question, but maybe for the panelists in the middle that represents the community of companies. So in AI and development of a product and science, and then you mentioned about the product, maybe the economical impact. I work with Native Americans. Sovereignty of data is very important. So I can promise them, and I think it's also applying in other domains. It's very important that we identify that we can advance science with data sets that are available to us or that are important for science, but in the community, they look at data differently. So this is either sacred data or sacred, like nobody should know about our data, but we want to know, and we would like, the Native Americans would like to get help, but the methods that we have for analyzing data is not the way that certain communities would like the data to be shared or look at. So there is certain barrier for impact, I think, if we don't look at this sovereignty or this ownership. Because we say, well, just give me a large enough data set and large enough computer, I can do wonders. Well, there are other barriers that are not so about the size and the amount. So maybe you and anybody else.
Two thoughts. One about how to enabling those communities to actually do the application of AI into that space. And then the second one may be about the bias associated with data sets, which somebody also just kind of alluded to. On the first one, it's great that we've got huge machines that, rival international capabilities and suck up all the power in the world. You know, there's this other communities that need open source and open standards that allow them to tailor their use of this intellectual development for their uses in their footprint. And so how do we transport that? We've said a lot about that. We need more. My perspective would be open standards and open source in order to do that, to allow those communities to apply that within their footprint. So that the first one, yeah.
And there is some AI edge computing, and there is a topic that is happening that, hey, we need to do it smaller and faster and maybe more, downsizing AI to allow other communities or other types of data being used. So I know there are some initiatives, but the access to data is not the same for everyone. And there, I guess that's part of the conversation. Communities need another speed and another size of
I
computation.
agree with that. I don't have any particular tools to offer in that regard. On the bias question, though, I think it is an incredible. We had a bit of a discussion in the breakout on trustworthiness and ethics. I think was which and this became one of the most key topics is using the data for purposes that it was intended for and realizing when you're going beyond that. And so IEEE actually has quite a bit of standards development influenced by research on how to document the data sets and do a bias assessment as part of the development of that data set and then its use within AI. So it doesn't happen to come out of this environment, but it is research driven with respect to bias of AI data sets and the outcomes that it might be applied to. It sounds relevant to the the sacred data that you mentioned. I think is very critical.
Sovereignty or a different understanding about how much can we even share with other scientists. So thank you.
Hi, I'm Rian Flynn. I'm a post-bac student at Purdue. Thank you all so much for your wonderful comments. Wondering about specifically when it comes to like industry versus academia, like it seems like in the realm of AI, it seems like industry is like just advancing so much more rapidly than academia in certain respects. Like they have more like, resources to throw at like LLMs and stuff like that. And I'm kind of wondering in the realm of like some of you were mentioning like open standards and the kind of like governance around AI, wondering how you think like academia can, like regain like the, I guess, like the vanguard of like that kind of AI development of, in terms of like standards and, around, data usage, privacy things like data bias and that kind of thing. How can we in academia like be the vanguard of that?
I can take it apart, but others would probably have comments too. We had the pilot present, the NAIR pilot this morning. A big driver for that is the presidential directive, the EO directive that came out on AI last October. Been about a year now, and that specifically calls for the development of open standards for the governance of AI and calls for across the board communities involvement, including industry and academia and NGOs and organizations that benefit or are potentially harmed by AI. And so that EO directive is really kind of essential from our government's perspective about how to get involved. It specifically delineates NSF to build a pilot. It talks about NIST running a consortium to be getting input from academic researchers and the like. And IEEE runs a set of standards activities that are built on researchers. They come in as both individual researchers, as IEEE members. Sign up now. It's cheaper when you're an undergrad. But yeah, for sure, a whole lot of opportunities to get involved in open standards development for AI now.
maybe I'll say something that can help for like locally and like what you can do. So I think there's a session, maybe the next talk that is on ML challenges. I mean, I've found that putting together data sets, but also benchmarks and challenges around interesting scientific problems has been really a great way to engage with the broader community. You know, it's like, okay, I'm not just doing, you know, MNIST or something like that. And again, but I get to do it for climate or for physics or something else, right? And then it also brings different challenges and things like that. But putting together benchmarks and ML challenges is a lot of work, and so I think that's a way that you could think of from the science point of view, bringing new challenges, interesting problems, unique ones, and getting people interested in those in applying their techniques to them.
Okay. So one thing I didn't hear talking about too much is networking and how networking plays a role in kind of harnessing the data revolution. So like I know I'm a material scientist, I have a lab. I have systems that can generate 40 gigabits per second. And I'm stuck with it. I begged and paid a lot of money to get a 10 gig pipe that gets me 2 gigabits out. And if we're starting to talk about these training large models, we have to, you have your data in one place, your compute might be somewhere else. And how do you, like, what do you see as a vision for a future of how you deal with that problem of being able to have data that exists in different places and compute that exists in different places, and building that infrastructure to enable kind of us to actually harness the data revolution? And then from a policy side, how do you deal with that data has to move in secure and meaningful secure ways between different institutions, and compute has to happen on different institutions?
Guess I'll take first crack at that. I mean, certainly resource providers are constantly worried about data movement. We've been worried about data movement for many years. We do our best to fund the best networks that we can put into place. And generally speaking, if you give our networking people any sort of free reign, they will justify upgrading our network connection. And anytime there's a spike that is over 50% of the capacity, I think so. So they are quite gun ho to keep our circuits up as much as they can. The issue with data being in different place from compute is also a very important one, and one that's going to remain a challenge, I think, pretty much forever. So we are typically funded to do one thing or another, and it's not usually to provide long-term data storage. That's actually something that NSF doesn't like to fund terribly much. You have to have a specific community need for long-term data storage more typically. So that's easier to fund than a general data repository. But I think the other answer is it takes a village. I mean, one site isn't going to be able to be all things to all people. They're going to have different types of providers around the country that provide different services. You know, some of us here provide traditional HPC, some data. There are others within our community that provide cloud services. NSF provides funding for projects like Cloud Bank that provides access to commercial cloud services as well. So there's a wide variety of ways to get compute and to get storage, but there will be data movement that will be required for that, or you'll have to pick the compute that's closest to your data, I think so.
Well, I just actually wanted to, I just wanted to answer that, or help answer that question about networking data storage. Yeah, I just wanted to help answer that question about data movement and things like that. I mean, the NSF this morning talked about Pelican, and that's a project that basically tries to do that your data lives somewhere else and you can then have an interface to it. But there's also CC Star and things like that that help, you know, buy storage for your local school or your networking for your school to help with that. So just sort of to advertise that as a project that's in the pipeline. Oh, did you also have a question? No.
I just, yesterday we talked about knowledge guided machine learning. Knowledge requires prior, to build those models requires prior knowledge. When people develop these models, they come from different backgrounds. As a result, when we are looking at the model as we're using it, which is the posterior part of the machine learning, we're using it. Sometimes we discover biases, and those are things that could be addressed at the beginning while we're developing the knowledge base, which we need in developing any model the machine learning is going to be using going forward. So how do we make sure that people who have different background, different knowledge than we do are sitting around the table so that the final product is something that we can all use and they will not have all these biases at the moment of use. Yeah, how do we do that? How do we impose that the people driving this technology also have people around the table who don't necessarily look like them, don't have the same background, don't have the same knowledge, but they are sitting there while we're developing that initial knowledge.
Yeah, I will say this does not happen by accident, right? We cannot build AI models that are aware and that are sensitive to different communities and different biases without very intentional effort. This is an area where I feel strongly that academia does have a role and a responsibility to help in this way and to be very proactive. We have really been, to one of the last questions, a couple of questions ago, talking about how does academia kind of regain the vanguard. Industry has massive financial motivation to push this front of AI, and they're going to do whatever is profitable. But they have to, most of these are publicly traded companies, right? They have to align their efforts with what is profitable. And we know in our field that so much of what is good about research, so much of what is good in the world is not necessarily the most profitable things. And so I think this is really one where we have to pay attention, we have to be proactive, and we can expect things to go wrong a lot. And so there will be, both on the input side, being cognizant of how do I make sure that the data that's coming in is representative of what I want to cover? And then after the model's training, to look at what the outputs are and to see if this is actually working, if I'm actually getting the type of behavior and alignment that I desire. And there's just story after story of people getting this wrong, right? Where it comes out and it's biased. We don't want that. So then they align it, and they over align it, and they get something they really didn't want. I was so disappointed when I got the large code llama model working and it wouldn't give me any code output because it said it was a responsible AI that wasn't going to help me write code. So they were trying to avoid, too much in that case. And so I think we're going to fall off both sides of the path as we work on it. But this is one where we can advocate, we can use our labs. Fine tuning also is a much smaller computational load than these, the first training of these foundational models. And so as we build data sets that are valuable and make those available, open standards, all those things to help them be included. And then as industry creates these models and we are able to fine tune them, which is again a smaller task that we can also take on to be more equitable and less biased. Those are really, really great ways that academia can contribute. And you bring up a great point.
Yeah.
I can just give a plug for maybe two efforts led out of SDSC that might be of interest. So there's an NSF funded RCN FAR in machine learning, AI, readiness, and reproducibility. That project's led by Christine Kirkpatrick. If you have questions, you can talk to Kevin Coakley in the audience about it. But that's really focused on creating on-ramps for disciplines and stakeholders who have knowledge, as you were kind of hitting on, that would be really critical to developing that research and that work, but don't have those on-ramps available right now. And then I'll also just mention kind of more on the education and training side of that. We have the CORE Institute, Convergence Research Institute, which is led by Ilkay Altintish and her team. And they developed a methodology to be able to figure out how to replicate the successes that they've had engaging with stakeholders and communities on machine learning, AI, or other data and computationally intensive research. And so you can just reach out to me if anything related to that is of interest, because there would be ways to either tap into the existing structures that they have through that program or even replicate it for any of the HDRs here in the room.
Thank you. As we wrap up, I guess I have one question for the panelists. If you have one thing for people to take away, for people to do from this HDR conference into their project, into their everyday work in terms of community engagement, what do you think, or what would be your advice for the audience? Maybe just give one line.
Yeah, so there's one really good comment about like it's community engagement gets inherently local, which I think my original comment was about, which is trying to figure out how to amplify your local impact. Because I always feel like, okay, if you're right around, like I'm from Fermi Lab, I feel like they get it. The people that are local there, you have a ton of opportunities for engagement. But thinking about how to do that, especially with data and AI, and how to amplify those things that we're doing to places that reach further than we can see locally. Thank you.
Yeah, I guess I'd just say that there's so much great work that's been done through the HDR projects, and there are so many lessons learned. And so I think just really focusing on leaning into those and taking those forward as a foundation for future work in this space is really critical.
Yeah, I echo the amount of work that's gone on, and the results that are coming out are great. Spend a few minutes every day thinking about where else you should take your results, how to get them outside of everybody lives in a bubble, right? So how to get it beyond your bubble, how to introduce to new people, how to get to new communities. Spend a little bit of time all the time thinking about that.
Thank you.
Yeah, and to piggyback off that, funded grants generally have broadening participation. I would say be intentional with what you propose in broadening participation, and take a little bit of time to think about how you want to use that. I mean, essentially, we all have a paid sliver of our work that we're able to use to go do community outreach and to change lives in that way.
I think I'll wrap it up by just saying, put this somewhat on you. We all have programs, all the resource providers certainly do, for outreach and that sort of thing. Think about how you can help us reach communities that we're not reaching. We can't do it all on our own, but we're happy to help. So if you have ways that can engage underserved or minority communities in your area, please help connect us, or help do it yourself. But we really want to help and be part of the solution.
Thank you all. Thank you to all the panelists, and give them a round of applause.
Yeah, thank you. And thank you to Anand for moderating this. Okay, so we are so we budgeted an hour and a half for lunch. That's probably too much time. So we'll probably, I'd like to see, do you think this session in 45 minutes, we good? I think we have like four or five 10-minute talks. So 45, 50 minutes, and we'll have plenty of time for lunch. And there'll be an announcement before lunch about a special little a special event. Okay, so this is the session. So we just heard from several of the speakers, including several of the panelists, how one of the ways to engage the community is through AI and data infrastructure, but also Nan was mentioning about the challenges. And so through leadership of Phil and Josephine, we have a program of work within the HDR ecosystem to develop and run machine learning challenges. And you'll hear about this from Phil. And so this is really a gem of the HDR ecosystem program, and something we very much want to highlight during this conference. So you'll hear from several talks on different parts of the challenge, and you'll hear an overview from Phil Harris, who's a professor of physics at MIT, and also a deputy director of the A3D3 Institute. So go ahead. And I'm going to be moving a few chairs. Don't get distracted.
All right. So yeah, so I want to talk about the ML challenges. So thanks, Mark, for the intro. Yeah, so the idea here is we want to reach out, build, highlight important scientific problems that we don't think are being addressed, or at least not being highlighted by the rest of the kind of machine learning community. And so the idea here was first to align ourselves across the HDR institutes, and come up with a kind of scheme that we think is appropriate for the HDR, kind of under the lines of HDR, but more generally, allows us to connect the different communities and highlight problems that we all think are very important. So we started a year ago to align this. We started with all 5 institutes. We did a survey of problems. We typically thought that a kind of anomaly detection would be interesting. So anyway, before I go into the details, why don't I just say, why do we want to do this? Well, there's many advantages of ML challenges. And historically, these have been kind of drivers for kind of major, changes in machine learning. I think many of you might be familiar with ImageNet, right? So this is what kind of motivated the design of image-based neural network algorithms, including AlexNet, VGG, and ResNet, and others. Within my community, there's the Kaggle-Higgs boson challenge. So, suddenly, everybody on the street knew how to discover Higgs bosons. And I think there were like 200 or 300 submissions. So it was a great way to highlight some of the important problems in our field. What really makes the ML challenge important, though, is that these data sets live forever, right? The ImageNet challenge, it started as a single challenge, but that data set is still being used today, right? We still use this to, study image algorithms. And that's the kind of big highlight of ML challenges. Now, to take some slides from my colleague Jan, I kind of want to highlight, one thing we can learn from the ML challenges. And that's actually, in the context of A3D3, we're always trying to understand how do we make neural networks faster and run on more data, right? So we have this plot, where the y-axis here is the data rate and the x-axis is latency. And we're always trying to make things fast and high data rate versus slow and low in the bottom right corner. And one way to really understand the bounds and the kind of computational limitations of this is to take a variety of models, right? And then just plot them. And then out of this, you can end up with kind of the computational limit, or the Pareto frontier of your models. So the thought here is, well, we can start with some ML challenges, highlight important scientific problems, and we start to build kind of an emerging knowledge out of the problems about what's critical for ML design, what's critical for scientific issues. And this allows us to kind of learn more generally about the kind of bounds of our capability with ML and our capability of deploying scientific problems. This year, we will focus on anomaly detection. We're going to work, 3 of the 5 institutes have submitted challenges. So we're going to look at biological anomalies from imageomics, gravitational wave anomalies from A3D3, and sea level rise. And so you'll hear about these different challenges in the subsequent talks. What is anomaly detection? Well, the idea is, given a data set, you want to find something that's different, right? So here you have an image of flowers, and there's a very obvious red flower that differs from the others. The reality, though, is that this is much harder than just looking at a field and seeing the obvious differences. It's actually more like trying to find some subtle difference. And I'm not talking about where's Waldo. Waldo is easy to find. The challenge that I would ask you is, find all the dogs in this image, right? It turns out there's 3 of them, actually 4, I think. And the point being is that you need to look at the data. You need to understand what's regular. Here you have an image of a bunch of people, goofy people running around, and you need to then ask yourself the question, what's different? And the idea here is we want to train a machine learning algorithm to do all of this, right? This is a rather hard problem. It's a very scientific problem. And it's something that kind of doesn't have well-defined rules. And so it makes for a great challenge because it's hard. Now there are kind of simple ways to do this. There's things like autoencoders where you can, try to map the regularity of your data by just training a neural network to reproduce the data. And just looking at its ability to reproduce each of our kind of images or events or whatever. But there's many other kind of more sophisticated approaches that are kind of emerging. And the point here was to see if we could actually have some sort of scheme of algorithms that could work for kind of different challenges, but possibly also could work for many different scientific problems, right? And the hope here is to highlight, new and possible ideas. So how do we do this? Well, we need a data set. We need a framework for hosting and scoring the challenges. And then we need some motivations, right? So we need some awards and ceremony. And so this is what we've been working on the past year, putting this all together. And so we've decided first to make sure everything is fair. This is an HDR conference. I think you all know, fair, findable, accessible, interoperable, reusable. And this has been a major focus. And we're not just talking about making fair data sets. We're talking about making kind of fair end-to-end workflows. So here's just a kind of diagram of a completely modular workflow from the imageomics paper. But the idea here is that we want people to not only be able to submit their challenges, but to kind of, when they submit it, there's a full kind of backbone that tells us exactly how we could reproduce their model and their data and their inference. And so our scoring is not just kind of robust in the sense that, they submit, we get a score, is robust in the sense that, I could call you up and kind of yell at you code, and you could write it on your computer and actually get the same result, right? So we wanted to make things as reproducible as possible. I'll talk a little bit about this in a sec. We also decided to work to host the challenge on CodaBench. CodaBench is a kind of scheme like Kaggle that's hosted about over 500 challenges. So it's kind of a competitor. We're friends with the kind of founders of CodaBench. The actual kind of CEO, founder of CodaBench has come to our meetings. And the nice thing is that we've been working with the NERSC group. So this is a DOE computing cluster at Lawrence Berkeley Labs. And they've actually provided computing resources for us so that when we go onto the CodaBench website and you launch your challenge and you submit your jobs, you actually get sent to NERSC. And the jobs actually get run on the big NERSC computing cluster. And so adding all this infrastructure was a little tricky. And actually, the most tricky part was being able to make this fair and reproducible. And I'll mention that in a second. All right, so we have 3 of the 5 institutes featured here. We very much would like to have the other 2 in future ML challenges. But the hope here was to come up with a problem that we could kind of align across the different domains. And you'll hear about the problems in a sec. In addition, we're going to have a combined challenge. And so how does the combined challenge work? Well, you can submit a challenge to each of the 3. And then the sum of your ranks in the 3 challenges will then give you a combined challenge, right? And so we'll have a 4th challenge. And you can go to our website and you actually can see scoring from the different challenges as well as the combined challenge. Now, just to mention, the workflows are completely fair. So what does that mean? Well, the GitHubs are public, right? You can see the QR codes here. And not only that, the scoring, submission, data preparation, all of this is available on GitHub. You can see this. We actually decided to centralize the software. So there's a common Docker container, which you can also see how we constructed it in GitHub. And not only that, when you submit your job, you actually list the additional software packages that you need. We cross-check this against a whitelist of allowed packages, or allowed packages that NERSC would support. And then it will actually install the packages and run your workflow. And so in this sense, right, you can submit whatever you want under very broad constraints, right? And it's completely reproducible. And just to note, right, the kind of questions we asked, these were actually kind of new to the CodaBench team. They were surprised that we wanted this level of reproducibility. And so I think this is a highlight of the work that we've done in the past year. All right, so here's some details about how we run on NERSC. I think the important thing is that everything is fair and reproducible. And we will launch the challenge today. You'll see a kind of launch video later on. And we're planning to end the challenge in January. And we'd like to host an awards ceremony at the AAAI conference in Philadelphia in March. This is to be confirmed, but I think we hopefully will have that. In addition, we're preparing a document to cover all the different work that we've done, to assemble the data sets, make sure things are fair and align the problems across the different domains. And lastly, just to mention, we actually do have some sponsors for the awards, but we're certainly seeking more, right? So if you're interested, if you know industry who would like to sponsor this problem, that would be great. Beyond this, we like to see this as a cornerstone of kind of connecting the different HDR institutes. And we'd like to make sure that we expand this even further. And so please come to our session this afternoon and we'll talk more about what we'd like to do for the next future ML challenges. And we can, in principle, host them for the next 3 years. All right, thank you.
I'm going to make, in the interest of time, that we see all the presentations in this block and then have questions at the end. Does anyone have a problem with that? Okay. You okay with that, Phil?
Yeah.
Okay, you're the next speaker.
All right.
No introduction needed.
All right. So, yeah, I'm unfortunately giving the talk for A3D3. This is really work. I'd like to highlight the work Katya and Yuantong and Adi, who all actually did the hard work of preparing the challenge. I'm just the person who came to the meeting. As you know, A3D3 is about trying to get kind of low latency, fast inference for real-time processing of big data. And in this case, we try to look in the context of multi-messenger astronomy. So we're using data from the LIGO detector. So the LIGO detector, it's actually 2 detectors. And it's an interferometer, and it tries to measure motion of gravitational waves. So gravitational wave will distort space-time. And the distorted space-time will modify the traveling path of light. And these modifications can then come up as interference patterns. And so what we see is that light will move a little bit. And then you'll see a change in the way the light kind of interferes with itself. Right? So here you have a gravitational wave. And suddenly you'll see changes in intensity of your light. And so the strategy is to do this and then measure gravitational waves. Just as a note, the kind of motion we're talking about is 10 to the minus 21 meters. So you're talking about motion that's actually smaller than the nucleus of an atom. How we get to that level of sensitivity is remarkable. And it's not something I'll discuss now, but it's certainly an exciting challenge. What does this look like in practice? Well, what you get is data that looks like this on the bottom. This is your intensity of your interferometer. And traditionally, we know what the signal is. And so we just do kind of a dot product of our hypothetical signal with the data. And this top guy is our dot product. And so you can see, you go through the time, you get a dot product, you see a signal, and that's the time of your event, right? And you just keep running this through. The challenge of anomaly detection is, what if we get rid of this purple guy and we just look for something that should be astrophysical, but we don't actually know what the shape of this is, right? Now, there's some guiding principles about how these things can work. There should be a line between the detectors. It should possibly look like some hypothetical astrophysical signal. But that's really all we have. And we do see astrophysical signals. Here's some examples of black hole mergers. These are kind of conventional things. But here we want to look for unconventional things, such as supernova. And the hope here is that we could see this with the LIGO or other gravitational wave detectors and alert the rest of the world, right? Tell radio astronomy that there's an event, and then they can point their telescopes in the sky and see this. And so we want to do this as fast as possible and as unbiased as possible. So we have actually a pipeline. This is a A3D3 pipeline for how we do this in LIGO. It's up and running. It's making alerts. And the anomaly detection algorithm, when we have one, would live here.
we do have a prototype algorithm we called, GWAC. Skip this slide. And GWAC at the moment takes kind of all of our known astrophysical things, constructs a multidimensional space, and then tries to compute a likelihood for something new, right? Within this multidimensional space. So you can think of it as like, clustering in a latent space and then looking in the region of the latent space where there are no clusters, right? So that's kind of the idea. And so that's an algorithm we have that, we've prototyped. And we can see various, different astrophysical signals with various different, rates by looking within the space. And we can see things like supernova, white noise bursts, and kind of even more crazier things. That's kind of been the baseline for how we actually deploy this. And so for the ML challenge, we took the kind of same data set that we used to build this algorithm. And then we added a bunch of, hidden signals. And so you'll have things like background on the left, which is just noise. You'll have some signals like on the right, which these are black hole mergers. So these are things we kind of know how they behave. But then we have some kind of mysterious signals that we're not going to tell you what they are. Right? And these could be from core collapse supernova. These could be from, other astrophysical events. It could even be strange, kind of unexplained things like sine Gaussians at specific frequencies and so on. And so that's the challenge. We have a background. We have signal data set, which is a bunch of kind of hidden simulated signal samples. We've never seen these in reality, so we're just guessing. But we're not going to tell you what these signals are, and they're going to be hidden. And there's going to be a test data set with some hidden signals that you can test on. When you submit your challenge, this will go on the leaderboard. And then when we actually do the scoring, we have a super secret data set that we only will use for the scoring when we close the challenge in January 17th. So that's our challenge. We're going to actually, we have lots of hidden signals. So we're going to actually take the top 50 events and rank, how many of the anomalies in your top 50 scored events are anomalies. So that's the whole challenge. What this means in the future is that currently we're actually taking data. This is LIGO Run 04. If your algorithm works really well, it could actually run in LIGO 05 with our pipeline. So that's it. Thank you.
Okay, thank you. We have two other talks talking about from other institutes that are driving the machine learning challenge. I think you were next on the agenda. Okay. Change the share real quick. Use the microphone. It's probably better to use the microphone. You want to get yourself introduced?
Yeah, sure. Good afternoon. I'm Shubhankar. I'm a PhD candidate with iHub, and I'm excited to talk about machine learning challenge on anomaly detection, sea level anomaly detection. So the vision for iHub is we work on understanding the response of the changes in the polar region on the sea level rise. And we do that by integrating both polar science as well as data science. And this is done by using methods such as physics-informed models or as well as data-driven models like deep learning models. For our mission, we conduct data-intensive research, education, outreach, and cyber infrastructure development to understand the effects of the change of climate change on the polar regions. Yeah. Now, the climate change is a very important or a pressing issue in the present day, and this has effect not only in the ice sheets but also in the sea level elevation in the different regions, like the different coastal regions, for example, in New York or other regions of the world. So, if you look at the projections to the right, you can see that the sea level changes in the past century, like till the 20th century, used to be around like 8 inches. Or that is the average changes in the sea level elevation. But one of the biggest or the starking changes projections is that by the end of this century, it is projected that the sea level elevation would increase by on an average by 3 feet. Which is a stark difference from what it was in the recent past. Now, Earth's climate history has shown that any of such changes can have, like changes in the ice sheets can have such changes in the sea level elevation across the world. And obviously this can have regional impacts because it is not uniform across the different coastal regions. If you look at the population of the coastal regions, especially if you look at the US, the population in the coastal regions is about 160 million. There is about like half of the total population of the US. But if you look on a global scale, it's about like 11 of the 15 largest cities in the world lie in the coastal regions. So this can have, so any changes in the sea level rise can have an effect on the livelihood as well as financial implications, such as it is projected there is $6 billion a year right now to $1 trillion, let's say by 2050. So that's a pretty big impact, not just in the livelihood, but also financial impacts. So if you look at the measurements of how the sea level elevation is measured, to the right is the JSON-3 satellite that actually measures the sea level elevation on the oceans. And that is one of our primary data sets that we'll be using. For the next 30 years, if you look at other projections, such as the sea level elevation along the coastlines, on average, it is projected to be 10 to 12 inches in the next century, which in the next 30 years, which is approximately the same that it was in the last whole century. So the sea level is increasing at a starkly high rate. And this can also have an impact on the tide as well as storm surge heights. And this can lead to more flooding instances as well. So with respect to our data set, we have satellites that track the ocean sea levels. That is to the left. So it's basically the JSON-3 that we were showing in the previous slide. So those are the satellite data that we have of the ocean sea level elevations. And also we have ocean buoys across the different stations on the east coast of the US. And that can give us a more finer values of the sea level at the different cities or the coastal cities of the eastern US coast, US East Coast. So if you look at this specific slide, this focuses on the Atlantic region that is to the east of the US. And this specific region gives us the sea level elevation in the Atlantic Ocean. And we are focusing on how the change of the sea level elevation in the Atlantic Ocean can have an impact on the sea level elevation of certain specific stations on the US East Coast. And that is what our challenge is trying to focus on. So for our data set, what we'll be providing is, we'll be providing 30 years of the sea level elevation on the Atlantic Ocean. That is the yellow region you can see. So basically, we'll be providing 30 years of data that is from 1993 to 2023 of the sea level elevation across the whole of the North Atlantic region. And also, we have 30 years of data of the sea level elevation across 12 stations on the US East Coast. And for 20 years, we'll be providing them 20 years we'll be providing them as the training data, and 10 years we'll be holding out to test their submissions with respect to how their model performs. And that is what we are focusing on, and we have metrics such as the F1 score. So primarily we are asking for them to be able to detect if on a specific day there was an anomaly or not in either of the stations, or if they can predict correctly across all the stations. So that is our main challenge here. Thank you.
Okay, and like I said, there'll be time for questions at the end before lunch. The next speaker is Elizabeth Comblongo, who's from Ohio State, who's a data scientist, mathematician, and quantum researcher. So you could either use that microphone if you want to walk around.
I do. So I have to click anyway.
Oh,
Oops. Try to escape.
There we go. Escape. It's it's really not. It's kind of painful, honestly. Okay, and then the share. Oops, it's not better. And then I want to share this one. And get rid of this stuff and go to your channel. That's you, right?
Yep.
Okay. And then there's more clicking. Hold on. Oh no, that just came up. Okay. Except for one little thing, let me get rid of me. I don't know why it's showing you. Okay, there you go. All right.
It's your man, right? All right. Oh, it still has the bar. Can we get the, yeah. Oh, there we go. Okay, that worked. Fabulous. Okay. Yes, I don't want to cover up the special thanks to our fabulous team. This has been an excellent team effort to put together an anomaly detection challenge with hybrid butterflies. Also, Harry Chow and Hilmar Lapp, who is not able to attend today. But so Imageomics Institute, you've heard a lot about us, I think, over the last day. We use machine learning for biological discovery, especially focused on images. And so our challenge is trying to find hybrids among butterfly images. So first, I'll give you a brief history on the hybrid detection from the biological perspective. So a little motivation for our challenge. Researchers have sought means to detect hybrids since the creation of the field of taxonomy. By defining hybrids, it would give them the ability to better determine what is a true species versus a subspecies. Because in general, when we're looking at a species, they don't hybridize and produce offspring that can then reproduce. But when two subspecies mate and produce offspring, those offspring can then reproduce with each other again. So if they know that something is a hybrid, and they see it reproducing, they can then say, oh, well, this is not a species. But the big question here is, how do we figure that out? So how do we recognize a hybrid? What does a hybrid look like? If you have a blue mother and a red mother, are you going to get a purple kid? So Darwin started this question of what does a hybrid look like? And Mendel then, with his pea plant experiment, answered this with his hypothesis was that we would have a blending inheritance, meaning that traits are going to be inherited in a continuous fashion. So if we have a tall plant and a short plant, then we're just going to get medium, and now they're all coming down. However, what he actually found when he ran the experiments is that inheritance is often discrete. So our plants might look like one parent, and then in the next generation, you start to get a mix. What does this mean for butterflies? So consider these two species here. When they hybridize, you get a bunch of different patterns are possible. Some look more like one parent, some look like a mix of the two. This is because there are several dominant genes which control color pattern on wings. For instance, like that red stripe right there is a dominant gene. So that comes back through. So the dominance can make them look like one parent. And in practice, what biologists found is that identifying hybrids requires knowledge of the parent species or subspecies. Now, from the computer science perspective, a little background on anomaly detection. Probably one of the most well-known early topics would be consider banking. You want to find fraudulent or irregular spending or requests. So how many people have gone to travel and their credit cards, like, why are you at a supermarket over in Indiana when you live in New York? There's your anomaly. But we want to get something a little more interesting. So machine learning, you have questions on classification. Is this something that I've seen before, or is this something new? We get to computer vision. Now, another popular topic these days is autonomous vehicles. Did a pedestrian just run into the road, or is it a deer? Here we have a deer, but of course the model thinks it's a pedestrian. So, work in progress. As we keep adding these new layers, things get more complicated. And there has been some work in biology as well with gene function identification. So what phenotype anomaly resulted from a gene knockout, or phenotype is just what's like we're talking about with the stripes. So it's the patterns we see, or ecosystem health monitoring. So tracking a plankton population. You can say, oh, is this an anomaly? Yes, we should have an expert take a look and see what's going on, or no, we can move on and do a population count. So now on to our challenge. How can you help answer this important biological question? We have two butterflies here. No, sorry, we have three butterflies here, all from the same species. But we have two different subspecies, so subspecies 1 and 2. The two of them mix to create the hybrid up there. So you can see that these butterflies look rather, the two subspecies look rather different, and you get a mix when you have the hybrid. So in our challenge, you will see some subspecies, and this is our signal hybrid, is the mix of subspecies 1 and 2 here. But species A has a lot of subspecies, and they all look pretty different from each other. So 3 and 4 here are also still species A, but you can see they all look much more different. So what would a hybrid of those two subspecies look like? Or if we want to make things more challenging, you may recall from yesterday, butterflies mimic each other. So we have species B is the mimic of species A, and their subspecies 1 corresponds and subspecies 2 corresponds. And the question is, what would those hybrids look like? Now, in this challenge, nobody is going to see any of the hybrids except for a signal hybrid, but there are very subtle differences between all of these butterflies. And the big challenge is, can the model figure out, is this a hybrid or is it a parent species, and not get confused by the mimicry or the fact that, you know, subspecies 3, has, you know, blue forewings, and subspecies 2 has the nice little dots on there and there's no blue. So to do this, excuse me, we have our training data. So we have multiple subspecies, and we've selected the signal hybrids of those two subspecies that we saw up above. So that's our signal hybrid and 2 subspecies. And then during the development phase, as Phil mentioned, participants will be able to submit their models, and it will be run on this development set. And this will include all of the species A subspecies, which it has seen in training, signal hybrids from the training data. But now we introduce the challenge of those other species A hybrids, the non-signal hybrids, and the species B mimics. And these are the mimics of the signal hybrid parents and their hybrids. So they have about 1,100 images in the development set, and we double that for the testing. So overall, the challenge is to find the hybrids. Among species A and B, can your algorithm find the species A signal hybrids distinct from their parent subspecies? The species A non-signal hybrids, again, distinct from their parent subspecies. And the species B mimics of species A signal hybrids, but distinct from their parent subspecies as well. So we've provided a couple of baseline models, which are available for people to see. And here we have here under the precision recall curve results. And as you can see, when you're looking at the signal hybrids, it's a simpler challenge. But once you start looking at the non-signal or even the mimics, things get more complicated. And the models, then there's plenty of room to grow and improve on that. So I also have the graphical version as well. The blue is the mimic, the green is the signal, and the red is the non-signal with the most room for improvement. And that's all. Thank you.
Great talks in this session. And yeah, maybe if people have questions on any of the talks, if necessary, people could come back up and we could share slides. But if you have any questions on any of the machine learning challenge topics.
Thank you for introducing the machine learning challenges. I had one question. I wanted to know how will the results from the challenge be used? I think for the A3D3, you mentioned the best algorithms will be used in O5. What about the other challenges? How do you plan to use the results from this challenge? Thank you.
Yeah, so hopefully if the algorithms work well, yeah, we will very seriously consider this for O5. But yeah, it of course, right, depends on the score. It might be that we take these ideas and build them. Depends.
Yeah.
I'll-
Honestly, if somebody produces an algorithm that can detect the hybrids, it would be fabulous to be able to use in data cleaning, doing a first pass. When you collect a lot of specimens, it can be helpful. And yeah, we would definitely be excited to see any.
Yeah, I think so one of the interesting things about our problem is like we can actually, if anyone can model it properly, like with respect to the spatial dependencies of how the changes in the ocean actually affects the sea level on the coastal cities. I think that's a very, I mean, if that is, because that's why we have our evaluation in two ways, like if anyone can detect the anomalies at all on any of the days, and at the same time, if anyone can correctly check if which specific city the anomaly is in. So that's so even trying to model the spatial dependencies is a very interesting part of the challenge.
Let me just add an aside that, right, all of these are scientific discoveries that we're looking for, right? So really trying to teach an AI to discover something new, right? So broadly speaking, if there's an algorithm that works for any of these or even works across them, you know, you start to build up a way to kind of automate the whole discovery process, right? It's like a first step in that direction.
Any other questions?
I'm curious, just logistically, like, would it be the same algorithm for all three if you were like the combined challenge? Is it like, because the inputs are very different, right?
Yeah, so this is a lot of discussion, but the reality is that, you know, these are already, it was a challenge to get problems that kind of aligned in terms of the hypothesis and the testing. You know, we realized that they're probably going to be optimal solutions that are going to be different for each of the challenges. The way we do the scoring is by team. So you can sit and try to solve each individual problem, and maybe you have a better chance at winning. If somebody comes with a single algorithm that just solves all these problems, then I think we're, you know, we can declare this challenge like a victory, right? And you know.
Yeah, thanks. So other, yeah.
So my question is that, so what's your plan to advertise it to get participants that are more relevant to the field, and also encourage them to participate?
Yeah, we do have some awards. We have some cloud credits. I think we'd like to expand the awards. If you have people who are willing to sponsor this, it would be great. Our advertising starts today. We have a nice website. You can go, it's on the NSF HDR.org. You'll see a link to it. We wanted to first present it to the HDR community. But the plan kind of in the subsequent weeks is to start kind of advertising this broadly. I know the NSF has expressed an interest in actually, sending out a big announcement for this challenge. I hope that all of you in the HDR community can advertise this to your universities. The more people we have involved, the greater the challenge, the more interest there are in, scientific problems that we care about.
I guess after all, like if you get good algorithms in each of the challenge, you will go to the publishing a paper with the participants. Yeah, that makes sense.
Yeah, so we haven't, so we want to write a white paper already for all the work we've done. And I think we'd like to write a white paper on the results as well. That's the plan at the moment. That's right.
Thank you.
And also we expect that all the participants will be making their algorithms publicly available. That is a condition of joining the challenge, is at the end of the challenge, you will publish what you created. So that can be on GitHub or Hugging Face, somewhere that's publicly accessible so that other people can use it as part of that whole fair and reproducible process.
Yeah, that's awesome. Thank you.
Are there any limitations on who can participate? I mean, Phil, for example, can you participate?
Well, that would probably be an ethical issue at that point. But generally speaking, the more the merrier, as long as you're willing to follow the competition rules and not introduce more data into things as well.
But for example, other people within MMA in A3D3 can work on the MMA challenge.
Yeah, we never formalized this. Certainly the organizers cannot participate. So sorry to us. But I actually think it would be okay to, I don't know if there's any concerns, but this is a good question. We should finalize this, but I'm hoping that everybody can participate with the exception of the organizers.
Okay, let's do something. Yeah, oh, go ahead.
Hey, I wonder, do you know any state-of-the-art approaches to solve the problem? Well, it's probably my recommendation. You can, if you know, like in my field, I know some of the tools they perform is widely adopted in the field. Well, it's probably you can launch, they are open source. Your group can launch these tools and try to solve the problem and see the evaluation. Or you can send the invitation to the creators of the tools and just do a fair evaluation and draw the attention of the field. Which of the tools work the best to solve this problem?
Well, for our challenge, at least, our conversations with biologists revolve around the experts that are very well familiar with those particular species doing an analysis and generally require knowledge of the parent species or subspecies. And we attempted to address with a computer vision approach by using BioClip and DynoV2 to generate our baseline models to give a perspective on kind of, here's a starting point, go improve on that and give a reference. We don't know of any other big approaches that are out there that would be that targeted.
I mean, I think if your concern is about the labeling, right? We know the anomalies, right? There's the labels are well defined, right? We have tools to do this, right? So that was part of the trick of building this challenge, making it anomalous enough that it's a fun challenge, but knowing actually what the anomalies are.
Okay, well, thank you. We have a quick announcement before lunch. I'm going to take the liberty of just asking a really quick question. So there's winning the challenges in a GPU for bragging rights, and then there's winning the Nobel Prize and publishing something. Is it impossible that there's a discovery in the data? In other words, have the data sets themselves, because they're real data, it's not simulated data, right? For the most part. Is it impossible that there's actually discovery in there that, or has the team and the collaborate, have they so combed over that data that it's being released for fun, or not for fun, but for a collaborative challenge? Is it possible there's actually like a signal in there to be discovered? Like, I guess that's mostly the gravity wave, but also in any of them, is there publication worthy content, intellectual merit in there that somebody would be publication worthy on this data set?
So I'll comment on the gravity wave. So first of all, this is all publication level data, right? You can write a paper on this for sure. I mean, we have, but the data we're using is simulated because there are no anomalies. That being said, the actual LEGO data is open source and public, and it's exactly the same format. And if you want to go and search for something new, we can give you the import data set, the 3 lines of code to go from, fake data to real data.
And it begs the
actually search.
question of why you simulated data, not just the real data for the challenge for that example.
I mean, then you don't actually know where these lists are. Right?
Okay, well,
you need to be able to score this.
You could
somehow.
inject a signal through simulation into real data.
Yeah, so that's what we're doing.
Okay, it is real data. It's
real
not,
data.
it's simulated
Yeah.
signal data, obviously, because we want to, okay, but it is real data in the sense that there could be something anomalous in there that gets discovered by a participant. It's not impossible.
That's right.
Okay, that's all right. Okay, awesome. Hope that happens. Let's see. Emily, you want to make a quick announcement about lunch, and we'll transition to lunch now. Go ahead.
So for those of you who are pre-tenure faculty or postdocs, you hopefully got an email from me about this already, but there is a special networking lunch for you all. It is in the humanities room. If you head back towards the hotel, there's a hallway, you turn right, go all the way down to the end of the hallway. You will eventually find it. Look for the humanities room. We have 7 more senior faculty, including some HDR directors who have very kindly volunteered to be informal mentors. We're leaving it very open. We've tried to do structured stuff in the past, and the feedback we've gotten from the more junior people is we just want to talk to the more senior people and ask our own questions. So that's what we're doing. So grab your lunch outside and then head on down to the humanities room if you are a pre-tenure faculty or postdoc interested in this networking and informal mentoring event.
Great, thank you. Yeah, it's a grab and go scenario. So you get the lunch, but you just bring it to humanities if you're in this category. Thank you. And we're back at 2 p.m. sharp. So please come back. We'll start the next session. Hey there, how are you? Yeah. Oh, yeah, so okay, if you go, okay, you're at the right place. So if you go to over. There's a link to my presentation. Announcement. There you go. If you click on that, there's a link that's the because I'm not sure whether you got the email. I also sent an email a couple of days ago. There's a link to the Google Form. And you just, it's 3 questions. What day do you want to go? Actually, it's 2 questions. What's your name, email? What day do you want to go? And do you need a car ride over there? It's not And even if you didn't come with a form, they just want to know the count, you can still go. They just want to know how many, but go ahead and fill that out. It's only- Yeah, I noticed your session did not have a Google Doc associated, but if Phil was creating them, I would ask him. Because if you have a list of topics you want to talk about, he'll create, yeah, I just noticed yours, he's taking care of that. I noticed yours didn't have one, so. Okay, hi. Hi, Leanna. Sorry, I feel weird. Can you help out Cody?
Well, I guess like I'm on deck at 2 to introduce two education folks. Just making sure. I'm happy to do that. I just want to.
No, I do too much of the introduction stuff, so I would be really happy if somebody else did. Let me just see where you're at. This is Sarah and Alex. Is that okay? So Sarah, I got her. So she's on, so both of those speakers are remote.
Oh, okay. Really?
Yeah, Alex also is, Sarah's remote and yeah, they're both remote. So I can help you with the share. Well, they'll just screen share. But if you could introduce them, that would be super great. And there's, you see there on the plenary, there's like you can use that as a teacher. I will definitely I would love if you could do any of them you feel like you could. So sorry, I'm just trying to see what's happening. Okay, so lunch, there's Sarah, there's this, then there's the panel, and then yes, introduce Eric, and then Eric. Have you seen Eric lately? Can you just make sure he knows about all this? And like, for example, you noticed in the other panel that Anand actually had a little link to just the questions.
Yeah.
I don't have a link yet from Eric. Somebody
Okay.
should link something that allows him as the moderator to describe the questions to
Okay,
the ask.
to
So
the
there's some
panelists.
sort of content there, and he should
Yeah.
just let me know. He could CC
Okay.
you, just let me know. So if you see him,
Yeah.
if you could let him know that I don't either. That's the
Okay,
problem.
all right. But I do
We
know
have plenty- we
Neon
have
and I do
time.
know, so I will figure that out.
Somehow it should be communicated that if you can introduce him, and then he needs to have some sort of Google Slides preferably, or doc
Gotcha.
that I can then
Yeah.
post on here.
Okay,
But anything you can do to help on that, I'll assume you're going to introduce him, and you're going to introduce the whole block.
correct.
Excellent.
Okay,
Thank
and
you so
I'll
much.
have him email you.
Okay, thank you. What was your first name?
Yeah. You want me to check? Yeah. Oh. Oh, well, it's been recording. Good thing we didn't tell any secrets.
No secrets were told.
So it's 2:02. We'll get started at 2:04.
Okay.
Well, 2:03. We're gonna get started. All right, it is 2:03. So my name is Leanna House. I am from Virginia Tech and I'm involved with the Imageomics Institute, which was what luckily brings me here. And for some of us, we've noticed that there's education and outreach component, and arguably it's a requirement that NSF makes us do. But I have to say, I feel across all of the institutes, it is something that we genuinely value. And we're doing a good job, I think, of the best we can, at least, to try to be able to reach out to those beyond just our current communities, as well as to those within. So the next few talks are going to be really education and outreach focus. Our first one is going to be brought to us by Dr. Sarah Mutwally, who just finished her PhD in quantum computing from Keio University in Japan. And now she is currently working at Argonne National Laboratory, whereby she's taking on a lot of the outreach efforts there. And as you can see from her talk, she's going to be giving us a nice discussion about communicating science, effective delivery to any audience. So thank you for joining us, Dr. Mutwally. Please take it away.
Thank you, Leanne. I do appreciate that you allowed me to give the talk, even though I could not be there in person. So thank you for that. So as Leanne said, my name is Sarah, and today we're going to talk a little bit about science communication, which I feel is very important for any researcher or anyone in the tech field, or technically in STEM in general. But how do we make our communicating science more efficient? Okay. So why do we want to communicate science? I think that's an important place to start. Why is it important? Why do we need to? Especially today, I feel the research field, whether it's in AI or in data science or even in quantum, right? It is important and it touches the life of everyone, not just the people in science or in STEM. That's why I feel like it's important for us to be able to communicate our work. What does it give to the world? How would it be a part of our daily life? How can it impact us? To everyone, even people who are not necessarily in STEM, right? So that's one aspect of why it's important. Other aspect is, as scientists, I'm pretty sure that all of us at some point needed to write a funding proposal to get fund to do our research. But to be able to convince, well, the people with the money to give us money to do our research, we need to show them how important it is. And sure, we can write long proposals with a lot of numbers and graphs, but we also need to be able to show the importance of it, of how it's going to affect, again, people's lives, right? It is also important to inspire future scientists. One of the roles I play at Argonne particularly is I do mostly science communication, or talking about science to K-12 students. So I mostly work with middle school and high school, not even, undergrads or like people who already graduated, because I feel like it's important also for them to understand the importance of science and to be able to if they want to be scientists, to be able to choose which part of STEM do they actually feel more, you know, more, let's say, oh my God, sorry, English, to feel more, you know, attracted to or want to pursue when in their undergrad. Another thing is, again, like, you know, we spend a lot of time doing research, right? Like research is not an easy job. It is a very mentally taxing job. And we spend a lot of time trying to better the world, right? We're doing this because we want something better for the future. And if we cannot communicate that this is what we've done, then I don't want to say that our work feels useless, but like part of it is actually saying, hey, this is how I make this better. This is how I make this technology better. This is how I can contribute to making life better for people. So there is so many importance for a scientist to be able to communicate their work. But like, how do we do this effectively is the tricky part. First thing, which I feel like in my presentation, I usually, when people ask me about talking about science, I do not like to give a set of rules because I feel there is a room for creativity when it comes to communicating science to people. But the one thing that I'll be like, it's the only advice I can give people is know your audience and try to engage them. If I'm talking to, again, K-12 students, I'm not going to talk about, let's say, stuff that maybe they cannot relate to. Maybe I will use something from their daily life, how they interact with their friends, how they interact with social media, to be able to kind of like draw a picture and connect science to their lives, rather than when I'm talking, say, to people who work in a company that does a specific thing. Even if I'm talking about the same thing to both audience, it will be a different way of me delivering this information to the different audiences. So maybe the only advice I can give, or the most important one, is knowing your audience, right? So what am I trying to say? My goal is, okay, what do I want to accomplish? What do I need to deliver? What is the message? So I have to be clear first. I have to deliver a message. What is this message? Then I'll know, okay, those are my audience. What do they want me to hear? What do they want to hear? How can I make them relate to the message I'm trying to deliver? Okay, so everything, we have a goal, right? Like the goal of my presentation now is to be able to maybe, you know, trigger some ideas in people's head about how to communicate science to a larger audience, right? It could be to educate people. If I am a teacher and I'm teaching people in a university or say in a classroom, my goal is to deliver a message which is to educate them. It could be to change behavior. So every message we have has a goal. And science communication, in my opinion, it's either going to be to educate or to just spread awareness about a specific part of STEM. Okay. So what question can we ask ourselves when we are about to either give a science communication presentation or just talk about science in general? We need to know who are those audience, what are their demographic, geographic area, what is their professional background, if they have any. Again, if they're children or teenager, perhaps they do not have a professional background, but like their background about the topic that I'm specifically going to talk about. And again, what do they already know? What do they don't? And why should they care? Or why do they care about the specific topic? And an important note here is they might not care at the beginning, right? And maybe that's the goal of the talk, is to get them to care. So it's like the goal will be here to call for action. Like, I want them to care about the specific topic, but then the question will be like, why do I want them to care? Maybe it will be like a replacement question to that one. Cool. So it depends on what you say and how you say it. And I feel like, honestly, although I made both of those circles are the same size, but I feel like how do you say something can be more significant than the something you're trying to say, right? So how do I say it can be more engaging and memorable for the people I'm talking to than actually what I'm trying to say. Okay, so this is an interesting slide here because body language is very important, right? And I feel like it's even harder for me to talk about that given a virtual presentation. But even in virtual presentations, it is very important to feel like that the person speaking is engaging the audience, right? I use my hands a lot when I talk, and maybe it does not show much when I do a virtual presentation, but like in person, I also tend to walk a lot on the stage. And it is easier to engage with the audience, I feel like, in a non-virtual setting, like in an in-person setting, but we'll do our best, I guess, even if you have like to do a virtual presentation or a virtual science communication talk. Voice is very important, and it's one of those challenges that if I am given a talk in a large room, some people do not like to use microphones and be like, I have a loud voice. But I feel like, sure, you can be like, I'm not comfortable using a microphone, but it is important to remember that when you are given a science communication talk, it's also about the audience and not just about you. So, and I feel like using a microphone is a skill that people can learn, because it's like, where is the exact positioning of the mic? I don't want to be shouting exactly in it and like causing everyone to have headaches. So it's like a very important thing to use our voice. The last thing is enthusiasm. Enthusiasm is one of those things that are contagious, right? Like when someone talks about something that they love, something that they're passionate about, you can feel that the people will be engaged more in that talk, just because being enthusiastic about something, like showing you're passionate about it, can be very contagious. And people will be like, oh my God, like that person really loved what they do. What they do must be great. Even if it is not great, it's just the enthusiasm about it makes people feel like, yes, I really want to learn more about that. Okay, so cool. Now I'm about to give a talk. I know my audience to an extent, to the best of my knowledge. I did my audience research. I prepared the materials, and now I need to be careful when I talk about science of using jargons, which we use a lot in the research field, right? We use it a lot in papers. We use it a lot when we give technical talk in conferences about specific topics. But if I'm aiming again to talk to a general audience and people are not in my field, I need to be careful about the terminologies that I use, right? So what is a jargon? So a jargon, again, is technical terminology or characteristic idiom that is known within a very specific group, okay? For the examples of jargons, I'm going to use some quantum examples that maybe some of the audience know what they mean, or maybe they do not particularly know what they mean, but let's see. So for example, in the quantum realm, right, we have like the first sentence, for example, it says Grover's algorithm offers a quadratic quantum speedup for unstructured search problem. Now that sentence, I feel like all of it is very technical and jargon, right? Like if I'm standing in front of, say, K-12 student, like a student in high school, and I'm saying, yeah, Grover's algorithm offers a quadratic quantum speedup to unstructured search problems. I feel like the entire sentence is jargon, right? Like who's Grover? That's first. What does quadratic quantum speedup mean? What is an unstructured search problem, right? Like this whole sentence is like, I feel like it's very technical and it's very, I would say, complicated from like, again, based on the audience that I'm talking to. Now, if I'm standing in front of other quantum researchers who did some quantum research in algorithms, or even computer scientists who might not know who Grover is or what Grover algorithm does, they might understand the rest of the sentence. But if, again, I'm talking to someone with no technical background, the sentence is maybe I wouldn't recommend using it in a science communication talk. Another thing I'll be like, if someone asks me, what is the major challenges when it comes to quantum computing? And I will say, well, we need to prevent decoherence, right? And though decoherence as a word, people can know what it means, but we're like, what does it mean in this context when I'm talking about quantum computing, right? The last one is, again, a qubit loses its quantum state due to interference. We already talked about so we have interference, quantum state, and qubit. All of these stuff is like, what is a qubit, right? What do you mean interference? Again, though interference and decoherence, people can know what they mean as in the absolute, what does this English word mean? But like, what does it mean in the context when I'm trying to talk about quantum computing, right? So we can find better ways to talk about each one of those, right? Each one of these things, rather than saying, for example, a qubit loses its quantum state due to interference. I can first talk to people first about what is a qubit, right? First you can ask the student, the audience, that's part of the engagement, right? do everyone know how actual computers work, like the ones we use now? Do you know what is a bit, right? Like we're going to start from there. A bit is something that can be 0 or 1. And a combination of bits is how computers understand what information we give it and how it gives us information back, right? A qubit is a quantum bit. So it's like the equivalent of a bit, but on quantum computers, right? What is a quantum state? Like, cool. I'd be like, a qubit can either be 0 or 1, and in some time in the middle of the computation in a superposition of 0 and 1, which is another thing, right? Be like, what is superposition? Superposition is a probabilistic state. We do not know if it's 0 or 1, but we can guess like it's a 50-50 chance. That's what superposition is, okay? What is interference, right? Then can come back to be like a qubit. One of the ways to do it is using photons, which are like, you know, like a laser, like lights. And lasers or photons, like, right, can be both particle and a wave, right? And they interfere with each other, which messes up their state. So like, you know, this is part of the problems with quantum. So we can like, instead of saying like one short sentence that is full of technical background, we can like divide it into pieces and like, target each of them individually and like build a bigger picture. Okay, talking about analogies, right? Analogies are important, right? That's how we make something closer to the audience to understand. Like, for example, one of my favorite analogies when it comes, like most of the examples I'm going to use are going to be about quantum, but like, you know, we can discuss that maybe in the end if I finished early, if we have different stuff. If anyone in the audience have like a favorite analogy to describe something they're working on, I'll be very happy to hear some of those. But like when it comes to quantum, one question is like, how can it be useful? Like what kind of problems will it solve that the current computers that we have, supercomputers, right, cannot solve, right? And one of my favorite analogies is chicken. If I say, hey, the grocery store every morning needs to get a specific number of chicken to sell at the store this day. And if they want to know what is the optimal number of chicken that they can get that day, that will be enough for people to buy, there's so many factors that they need to consider, right? They need to consider, I don't know, the weather, how much chicken do people in this area eat, how much chicken can they get from farmers nearby. There's so many stuff like consideration that they need to consider, right? How far are these farms from the grocery store? Can they get there in time? There is a lot of factors. And one of the things that quantum computers are good at is simulating multiple factors, so many factors at the same time faster than classical computers. We're not saying that the computers we have today cannot solve this chicken grocery store problem, but we're just saying that it will take much, much longer, like years longer, to just consider multiple factors. Rather than if I use a quantum computer, then it might take like a couple of hours instead of taking like a couple of years, right? So that's like one thing that we're talking about. Chicken people can then get to understand what is happening, right? Another thing is another way to describe superposition, right? What do I say when I mean superposition? Let's say we're all sitting now, right, in the conference room. I mean, you guys are, I'm sitting at home, but like we're sitting now, and one of the things is like, what am I having for dinner? Let's say that's a question I'm asking, right? And one way to think about it is technically I can have anything for dinner, right? Everything, all kinds of food, like say Japanese, Thai, Mexican, Italian food, everything is possible. I can have whatever one of them. So for me, it's like, cool. There is a distribution, a probabilistic distribution of like these food, all of them I can have. And that's kind of like superposition because I can have all of them. And until I make a decision, I'll be like, well, today I'm feeling like sushi. Then this superposition then collapses and then, okay, I'm 100% having sushi. But until then, I was like, you know, maybe it's 50% sushi, 40% Italian, 10% Thai, something like that, right? There's like a probability distribution there. So that is kind of like what superposition is. And believe it or not, superposition is something that we encounter in our daily life, but it's something that we do not think about a lot. So it is very important that when we use analogies to talk about science, that we relate to the daily life of people rather than trying to get into the technical stuff right away. Okay. Cool. So again, engagement is important, right? Like at this point, right, if I'm talking to people about particularly quantum here, and we're talked about this superposition thing, I, for example, would ask, what other things in our life that is in superposition that we do every day, right? And try to see what comes to people's mind, and if it actually is an example of superposition or not, right? If I'm talking to different scientists, I'll be like, what is something in your field, a concept that is hard to explain, and what is a fun analogy that you heard it being explained, or that you thought about and use it while explaining someone this concept to someone, right? It is very important to ask questions, even if the audience did not like raise their hand and actually participate in answering, it will trigger them to think about it, right? It's like, you know, what is something? Like, can you think of a jargon that you use? Can you think of an analogy of something like in data science and machine learning and AI that is difficult to explain, and how can we make it simpler for the specific audience you're targeting? And I would like to hear some answers for those questions. So I'm going to try to kind of like wrap up, because I would like to hear from you. So another thing is like, try to tell a story with your talk, right? Stories are great. And it is, you know, we used to do bedtime stories when we were younger. Stories capture the audience because it has this sense of like, I'm intrigued to know what happened. I'm curious. There's the curiosity in it, and it's interesting. So one template for a story, it's called ABT, which is and, but, therefore. So it's like, try to, you know, use all those 3 words to talk about something in particular. I have an example here, and sorry, this slide is horrible because it has a lot of text, but you know, we're going to go with it for now. For example, if I'm just going to use and, so my starting, like the story I'm trying to tell is like, quantum computers has potential to solve complex problems, and they can process information exponentially faster than classical computers. Now, this sentence is not 100% accurate, because the exponentially faster is very, you know, like it should be an asterisk there. It depends on the problem, right? But let's assume that this is the sentence I'm going with. It has the and, right? Now I can add more to it to make the story stronger, or what I'm trying to say more, easier to convince to the audience I'm trying to talk to. So computers have the potential to solve complex problems, and they process information exponentially faster, but they're still prone to error like quantum decoherence and noise. Now I added more material now. The story now is more clear to the audience. I can go a little bit further and use therefore, right? So the same thing, but then I say, therefore, researchers are developing quantum error correction. So now like we can see like here, there is a story, and the story is like that there is quantum and it's great and it can be faster, but it still has some errors, and that's why we are, as a researcher, trying to build more reliable system and developing error correction techniques, right? So it is interesting to think in those terms, like the and, but, and therefore, when we are trying to tell a story. Now, I'm quickly going to talk about just making presentations. And again, I feel like there's a lot of creativity there, but I feel like science communication topics, they always talk about how to make a good presentation, right? Like, do we use PowerPoint? Do I use, I don't know, do I need slides to start with? Maybe should I just show some videos, right? So just like make the presentation simple, right? Do not let it be distracting. If you have to present some finding, use more pictures than text, but also do not use just figures without explaining what's in those figures. It's nice to have a combination of both. Colors are great, but also when you use colors are great, but they also are tricky, because one of the things is like, if you can know how big the room that you're presenting in is, the lighting in it is important. Some people are colorblind, so there's a lot of like, you know, things that needs to be considered if we're using colors or if we're using graphs and different font colors. So be careful of that. Using like the background color, white is always a safe way to go. Me personally, in a lot of conversation, in a lot of presentation, I use black with white text. I do not know why, but I like black background. I feel like it's less harsh, especially when we're making presentation for the eye. But just be mindful when you're of these things when you are thinking about making a presentation, right? Yeah, make the font readable. Okay, use more graphics. I would say do not have anything there that does not serve a purpose. one of the things that me, myself, and a lot of researchers do is we like to put a lot of things in the slide just because we think the more things, the more the better, but that's not necessarily a good thing. Sometimes we add more information than we need, and that kind of causes more problems. Yes, colors again is important, right? Like this slide is horrible. Everything about it is terrible. Okay, like for people sitting there, just like, yeah, I do not want to read it. And because it has like a gradient color in the background, it makes it even more difficult to choose a text color. So avoid stuff like that. And don't use silly sounds, which was here. Not sure if you can hear it, but do not use it. So sounds can be interesting and engaging, but do not use them just to use them, okay? So backgrounds and sounds and animation, right? It's important to not just read the words on the slides, right? Like you can improvise sometimes when we're making slides, we're so focused, but sometimes when we present, we think about something that we did not think about when we were preparing the slides, which is fine, you can say it. The slide is merely a guideline for you and for the audience to know what you're talking about and be able to follow your talk through. Cool. So I have here some materials that me personally enjoy when it comes to talking about science communication and being able to be a storyteller that maybe if someone wanted to look at later. And this
You
is
have
it.
5 minutes, Sarah.
Yes, 5 minutes. Great. For those 5 minutes, of course, if anyone have any questions or concerns about science communication, or if anyone have any quantum questions that keeps them up at night, we'll be happy to answer. But if not, I will be happy to hear any analogies that you guys may have used talking about your work or something that you think is very creative and help make your point clearer.
Thank you, Sarah. All right, I'm getting the microphone up and running, I think, maybe.
Maybe.
There we go. Hello, testing. All right, analogy. Does anybody have an example analogy? Or a question? Can we ask questions now too, Sarah?
Yes, of course.
Well, I'll start us off with an analogy, which I tend to use, and those in my institute might bark at me, right? So we have a new field called imagiomics.
Oh,
Tell
okay.
people we have a new field, imagiomics. They look at me with a funny face.
Yeah.
I say genes is genomics, as images are to imagiomics. I'm learning about biological traits where images are our primary source of data. In the same way that genomics is learning about biological information, primary source of data are the genes. There's an analogy, right?
That's cool. Yeah.
All right. Diane's laughing at me, I can tell. Do you have an analogy, Diane? Anybody else? Did you have another question for us, Sarah? I feel like there were two. No?
Okay. I think the analogy one, I mean, jargons. I mean, what is a jargon that's in your field that you think it's hard to explain to a general audience?
Biological trait. What is a biological trait?
Yeah, that is difficult. What is a biological trait, right?
All right, so we are nearing the end of our time. We're probably at our time. Again, any remaining questions for our fabulous science communicator? All right, so thank you so much, Sarah. Let's give a round of applause. Maybe she can hear you in the back.
Yes, thank you so much for having me. And yeah, please, I don't know, reach out to me on anywhere, on
Thank
LinkedIn,
you.
anywhere,
I
if
learned
you
a lot
have any
about quantum
questions or
computing.
anything. Yes.
All right, so here I'm going to thank you again, Sarah. We're going to move on to our next speaker. Oh, yeah, there he is. Great. Hi, Alex.
Hi, should I
Go ahead and share your screen.
should I
I'm
go ahead
going
and
to
share?
introduce you. Great. Right, so as you know, the theme of today's series of talks are really about education and outreach. And so with that, we have a fabulous speaker named Alex Pack, who is an assistant professor of chemical and biological engineering at Colorado School of Mines. Right, his research group focuses on the development of multi-scale simulation techniques and their application toward both fundamental understanding and engineered control of self-assembled macromolecular complexes. And lucky for us, he too values education and outreach. And as part of a collaborator here, Emily Freed, have put together this fabulous repository that Alex is going to talk to us about for the next, is it 15 minutes? Do you know your time?
10 minutes.
10 minutes, all right. All right, you got permission from the master. Mark said you can go over a little bit longer if you want. But nevertheless, please share with us, Alex.
Great. Awesome. Thank you for that introduction. And before I begin, I just wanted to thank all the folks who were involved in this project, this repository that I'm going to talk about today. I'm merely a representative for this group of folks who come from all the different HDR institutes, as well as the DSCs. So at the last NSF HDR Ecosystem Conference during the Ideation Expo, there was this idea that came up, which is that there's this need to create an online centralized repository that allows us to share and disseminate materials, primarily educational and outreach materials that have been created throughout this HDR ecosystem. And broadly, the motivation here is we like to be able to disseminate these materials, but also indirectly promote data fluency, showing examples of domain type of exploration of, data exploration of domain-specific contexts, as well as an informal way to engage the data science community in domain challenges and vice versa. So the goals for this specific project, focusing on this repository, in the short term, is to create a centralized repository that would be useful to members of the HDR community. But in the long term, we'd like to make this repository publicly available, as well as promoted to different public forums as a resource for students, educators, and people in the general public or the broader community. Okay, so this repository, the nuts and bolts of it is a content management system, or a CMS. And we made a wish list of things we'd like to see in this content management system. First is that we'd like it to be free, or at least have a free tier version that has all of the features that we want. And these features include things like being able to search or browse through the repository, being able to handle different types of data types and metadata, and also having applications, integrated applications, for example, the ability to make a graphical user interface that allows users to interact with the database in different ways, either through browsing or data entry. And finally, a major feature is that there'd be no need for an account to be created to actually browse the content, which is something that Airtable doesn't allow us to do. And Airtable is one of the CMS platforms we looked at. So on the right over here, we have all the different CMS platforms we investigated, and we looked at all of them. And out of all these choices, most of them did not work for these features. And we ended up going for something called Base Row, which looks very similar to Airtable if you're familiar with Airtable. Okay, so what we're thinking in terms of how this repository would be useful in terms of data entry and curation is that first up, we have members and affiliates of the HDR institutes, and they would have a point of contact at the 5 institutes, most likely the education or outreach coordinator or an equivalent position. And that point of contact would be a data quality check / data curation check, where then that POC could enter the information related to that educational or outreach material into the repository. And the way they would do that is they would interact with this form that we created, which has a little over 10 questions. Some of these fields are required and some of them aren't, but they contain all the relevant information, like what's the title, who's the creator, give us a short description. And the key thing here is we require a URL to the activity or the materials. So the materials or the activity would be hosted somewhere else, and the repository is more a collection of touch points for people to access those materials. Other metadata includes what's the format of the resource or activity and who's the intended audience. So the POC would fill out this form, and then that form, when you click on the submit entry to the repository, it would automatically populate the database itself. And that database looks something like this. So if you're familiar with Airtable, the interface is very similar, where each row is one of the different data entries, and then each column contains the different categories or metadata associated with that entry. And first, on the upper right corner, there's a search capability, which I'll talk about in just a second. And the other way you can interact with this information is by applying logic filters to either filter the information, sort the information, or group the information. This is a little bit more advanced, and we anticipate that most users of this repository would just use a search function. So the way the search function works is you just put in a string, and you can either by default have the rows filtered out based on any field that does a partial match to that string. If you want to browse through the information in a slightly different modality, what you can do is allow all the rows to persist, and instead your search will simply highlight the fields that match with your search criteria, flood in this case. For more advanced usage of the database, you can apply different types of conditionals and combinations of conditionals to apply filters or sorts or groupings. For example, you can say, I want the resource activity format to be a slide or a PDF, and I also want it to be a hands-on activity where the description might either be about floods or have something to do with Python. And based on this conditional logic, it would filter out which rows are satisfy those conditions. Okay, so with this repository in mind, I just wanted to report back about a workshop that ID4 hosted called Integration of Data Fluency into 6th through 12th grade education. It was this past summer in July, so a few months ago, and we had many participants across the HDR institutes also join us for this workshop. And the goal was twofold. First, to provide a forum for us to discuss what data fluency currently looks like in 6th through 12th grade STEM education, and then using ideas about best practices, actually have the participants create learning modules that could be used in the STEM classrooms or clubs, where the learning modules would combine some data set and some domain-specific outcome that is linked to the next generation science standards. The participants themselves included data scientists, domain experts, pedagogy experts, as well as teachers in 6th through 12th grade STEM classrooms. And if you're interested, we have the website down here that has the agenda and the details. So one of the major components of this workshop was we had a hackathon at the very end of it, where we created these learning modules. And from this workshop, which had of roughly 20 to 25 participants, we created 6 learning modules. All of these are aligned to the NGSS standards that I talked about earlier. And most of them are uploaded to this education repository that I'm talking about right now. The modules consist of lesson plans that are loosely based off of the 5E instructional model. So that's talking about elements of engagement, exploration, explanation, elaboration, and evaluation. And they also contain the materials, including the data sets that are required to explore the data and investigate a specific domain question or scientific question. So if you're interested in either of these types of elements, they're all available through this repository. So finally, the next steps are envisioning for the repository. Right now, we've completed phase 1, which is a committee level exploration where we created the prototype database. We've created this data curation form, and we've populated the repository with about 5 to 10 items. And now we're in phase 2, where we like to open it up to inter-HDR participation, where we like to get entries from each of the institutes and also solicit feedback, things like what sorts of metadata might be missing, or are there different interaction modalities, different ways you'd like to interact with each of these items that we've curated in the database. And through this feedback, we would iterate the database design. And a possible extension is having a separate database that's specific to data sets and curated data sets. In phase 3, what we would do is we would open it up to the general public, where we promote the existence of this repository through public forums, seminars, whatever it may be. Again, soliciting more feedback and iterating the design as needed. So with that, thanks for your attention. The link to the repository itself is a tiny URL link with the name HDR EDU repo. If you have any questions, comments, or concerns or suggestions, feel free to email either me or Emily Freed. Emily is also in the audience, so you can also find her after this talk if you have any feedback to convey. So thank you very much.
Thank you so much. Any questions? Or Emily, do you have anything to add? Maybe raise your hand if you have a question. So Emily is the one that if we want to reference or have additional questions, there we go. We do have a question from Diane. Well, but then he might not be able to hear you.
I can't hear anything right now.
Hi, Alex. I'm Diane Bogart. I'm with Imageomics Institute, and we
Hi.
do have a lot of different educational activities. We also have some team science kind of workshops and whatnot that we've run. So I'm just wondering, does there have to be like a data set component to things that we submit, or can it be more, you know, more hands-on workshop materials, agendas, things of that nature? What are you looking
Yeah,
at?
great question. So you don't need to have a data set. The data set comment I made was only specific to that workshop that I was talking about. But many of the educational activities can just be demos or how you create a demo. They could be maybe a lecture. They can be anything related to education and outreach created through this the HDR ecosystem.
Excellent. Do we have additional questions? Wonderful. One more round of applause again. Thank you, Alex, for sharing the repository with us.
Thank you.
All right. Our last component of this set of talks on education and outreach, as soon as I figure out how to. How do I? Oh. We'll get Mark over here. All right. How do we now close Zoom, or do I just? Yeah, I won't. Okay. Yeah. Perfect.
And then I think, yeah, let's see. Then I think you want to, if you could just pull up the, let's see. Oh my God.
I can help you.
No, that's
All right, so our last component for education and outreach is going to be a panel discussion led by Dr. Eric Sokol. Fun fact about Dr. Sokol is that he got his PhD from Virginia Tech, which is where I work now. So that was exciting to have that connection. He now, for the last 7 years, has been working at NEON along with our collaborator with Imageomics, Paula Maybe. And so he is here to lead the discussion on, what is it called?
I don't remember.
What's it called, Eric? Workforce Development and Education from Data Science Course. All right, thank you, Dr. Sokol, for leading this panel. Come on up.
All right, do the panel members want to come up and grab a seat?
Okay, we should be sharing that. Yeah, we're sharing. Oh, one more share.
All right, well, we're arranging the chairs. So as Leanna mentioned, thanks for joining us for the Workforce Development and Education from Data Science Core panel. And this was organized by Karen Chen, who's an assistant professor in the Department of Information Systems at the University of Maryland, Baltimore County. And Paula Maybe, who's the chief scientist and the observatory director of the National Ecological Observatory Network, which is where I work. And so this panel features representatives from 5 NSF-funded data science core projects, each focused on harnessing data science to address real-world challenges while advancing education and workforce development. The panelists will share their experiences and insights on how their projects are making a significant impact on both academic and community settings. And so we'll start off, I think each of you can introduce yourself and give, a 3-5 minute intro about your data science core project, or just a couple sentences if you want to do that. Just tell us, about your data science core project that you're representing. And yeah, how about we start here?
Okay, is the microphone's on? You guys can hear. I'm Mark Daniel Ward. I'm at Purdue University. Our data science core grants through the American Statistical Association and serves 300 students and minorities serving institutions.
Hi, my name is Hugh Liang. I'm a professor of the University of Tennessee at Chattanooga. Thanks.
Hi, my name is Amanda Phillips DeLucas, and I'm the director of the Baltimore Neighborhood Indicators Alliance. We are a self-supported research institution located within the University of Baltimore. We had a data science core program where we paired undergraduate students with community organizations on data-specific projects within the city of Baltimore.
Hi, I'm Francisco Jacobelli. I'm at Loyola University Chicago, and our data science core project was very much like Amanda's, but then so we paired students with communities, but those students were coming from many different universities. So we also interact with the universities to create a common curriculum.
Hello, my name is Fernando Moro. I'm an associate professor in civil engineering at the University of New Mexico. Our data science core project is about the curriculum of undergraduate students and bringing data science. Many of us are engineers, so we're exploring how to probably transform or maybe engage the students with data science.
All right, well, I'll kick it off with a question about community engagement and impact. And we can go down the line, or if somebody wants to, answer the question right off, we can do it either way. So how do you align your data science initiatives with community needs? And can you provide examples of how feedback shaped your outcomes? And what strategies ensure long-term partner engagement? And how do you measure community impact?
So I brought in our project, we have an interest on this engagement component. In addition to the classroom, we're doing a lot of outreach. So I have a poster I presented yesterday, and I have a little box here. You can see it's an orange box. It's actually a very cheap it's a low-cost sensor. So by these activities, it could be on the summer, it could be after school. We go to the high school, we go to middle school, we go to elementary school. We teach the teachers in a science teacher once a year. We take the kids to the train and they build the sensor on the train. So they understand the data when they actually build the sensor. It's an Arduino. They also could measure something that you were not planning to measure that day. So maybe they put the sensor on the floor and they start dancing, and that's a good thing. So you allow them to create something that is becomes their idea, becomes their data, and they want to get new data on their own. I don't remember the other parts of the question.
Yeah, and how do you measure impact?
Well, we actually did a survey. It was very interesting. And then we realized some kids, well, they all know how to write, but surveys are boring. So we actually changed the survey and we said, can you draw something about what you did today? It's more inclusive. So they, by asking different ways for receiving feedback, you get more information. I will let other people.
Same question or?
Yeah, I figure we can just talk generally about real world applications, community engagement and how you're aligning with the needs of the community, how you evaluate.
So in our case, again, our project blends several universities in the Chicago area and their students with non-for-profit community organizations that work generally in the Chicago or in Illinois, actually, in a big area. Now, there are many engagements there, right? But the community specifically, what we ask the community is to submit a proposal, 1 page, 2 page, of what their data needs are, right? And this is great because they dream a lot, right? And then they provide a data need that when we read it, we're like, oh, I mean, there's just not there. But can we do something for them, right? And what we have, one of the things that I think is really essential to our engagement with the community is that all of us, students and mentors of students, we all meet with our respective community representative, or someone from the community, right? Comes and we talk to them, we speak to them, we engage with them, and we try to find a solution to their data problems, right? So in terms of engagement, that's one way. We have many repeats over the 5 years of the grant. We've had many repeats, which is a good in terms of evaluation, it's a really good sign, right? We have many people that still want the services of our students, but our students want to get an A in the next class, right? So balancing all of this is really challenging and very, very interesting.
So our organization is primarily a warehouse of public and semi-public administrative data for the city of Baltimore. So all of our work, community engagement and otherwise, comes from this place of working with administrative data. So I would say sort of there are three priorities that we always put forth when we engage both with students and as well as community partners. And the first is that this is a long-term investment of our institution with the community partner. We're committed to maintaining that, and the Data Science Core Fellow is helping represent that one way or another. But us having that trust allowed some of those connections to build quicker than in other cases. So I would suggest either partnering with organizations who have those relationships already or building out partnerships that are long-term and sustainable. We also, our mission is to provide trusted, reliable, and actionable data. And I think keeping those core missions at the center of any projects also allowed us to make sure that that engagement flowed through the projects that students ended up doing. Interpretability is also very important too. We don't want any findings to be too complex for the community that they are being shared with. So making sure that the measurements that students are using match the goals and the needs of the particular community partners that they're working with.
Okay, I'm going to use a story to talk about the community engagement. This summer, we host a workshop, 3 days workshop. It's the quantum computing. We cover from the math foundation and quantum mechanics and quantum algorithm and quantum machine learning and quantum cybersecurity. So in the beginning, we thought maybe a few people might show up, but on the day then we start, 87 people show up, and a lot of them from the local industry like TVA, like the VW. And we have to, reorder our, to add our food, so to feed the, yes, yeah, thanks. And yeah, the second thing is that I think that we secure the funding with the Volkswagen and TVA, yes, for the data science program. Thank you.
Should we segue into the real world application? Is it okay?
Whichever you want to do.
It's okay. I mean, I'm looking at the questions and, with regard to the real world application, our project has some similarities to our collaborators, but it tends to be more proprietary data from companies, often from for-profit companies from national labs. As an example, we focus a lot on aerospace engineering and pharmaceutical science, manufacturing, things like this. And, thinking ahead down the questions towards sustainability, what we've done is we've got the companies working on these 9-month projects with students at the graduate and the undergraduate level. We'll put 3 graduate students and 9 undergraduate students on each project. So, they have a range of different expertise across the sciences. They might not even all be in STEM majors. There's, I think, 160 majors represented in our program now. And the companies are paying just $20,000 for a project like this for 9 months. They get these 12 human beings to work with them. So it's really cost effective, and we think we can do it far beyond the auspices of the DSC program. And inevitably, after we've worked with the company for a year or two, the people and the problems and the nature of the business and where things are going, and then you can articulate a sponsored research contract with that organization. So yeah, at any rate. Hope that hits on a couple of the questions there.
Yeah, thank you. And if there are any others you want to jump to, feel free.
Okay, I can talk about that. Sorry about that. I really leave. Okay. Yes, I can talk about the research part. So yeah, when we propose our work, we just human-centric AI. That's the topics. So and we have the 3 projects, I think, received the federal funding. Yes, because the first one is AI, it's a physical therapies. Second one is music therapies. And the next one is the transportation management for the vehicles and the pedestrian. And thanks for the support of the DSC. Thank you.
If you want me to provide some guidance, I'm really interested to hear more about workforce development.
Sure, I can jump to that one. Thank you. So also in my capacity, I serve on the mayor's workforce development board. So I get to uniquely kind of occupy two spaces, one of working with students who are preparing for workforce and the other of sort of seeing the workforce needs of Baltimore City. And I think one thing that unites those two is sort of placing students in quality jobs. And so on the board side, that's defining what a quality job is. And I think on working with undergraduates, it's been preparing them for quality jobs. We are at the University of Baltimore, which is a very small institution. It's a very under-resourced institution. And I think that might differ from some folks in the room who might have like clear pathways for your computer science or your data science graduates. You might have really good connections with industry. We don't. So data science core for us has actually required, I think, a lot more one-on-one mentoring than we necessarily have capacity for in our organization and that we were really prepared for. So some of the things that I've just really noticed is this high level of support that students needed, both in sort of defining a project and sort of setting those research goals and being able to progress through with it. But more substantially is our students are kind of lacking in pathways to develop kind of the shared norms and expectations of the workplace, which we know is a very pressing issue for minority students, for students from underrepresented populations, or from those who are coming from lower socioeconomic backgrounds. And I think that it's always important to keep in mind that the data science workforce is not one workforce, and it's going to require a lot of different skills to raise different groups up into those quality jobs in the future.
Okay, so I second again a lot of that because when we work in Chicago with multiple institutions, the student body is very diverse. And you have a well-prepared student that went to a really nice high school, went to a very good university, is stuck in that university in those dorms forever, and for fun works as a waiter. And then we have other institutions where the students have to take care of their families, their immediate families, and their parents that live in the same house, and they go to study, come back to school, hope for an A, right? And they're very, very different. They're very different. And so for us, one of the challenges has been to put them together. And so preparing for the workforce, right? Put them together. You go to your job and you're going to find people from all walks of life, hopefully, right? So that experience has been good for both kinds of students. And then we have students in the middle as well, right? It's been good for all students. The fact that, like I mentioned earlier, we meet with our client. So we meet with the community organizer. We help them shape their idea about data and what is possible and what is not possible, right? That interaction with the actual person, right? It doesn't happen somewhere else. The students come to this. They meet, and they meet once, twice. If they need more times, right? So those are, I believe, the things that really remain for the workforce. Whether they use GitHub or R, that prepares them for their first job, right? So skills are GitHub. But interpersonal skills, being able to extract an idea from a client, being able to work with people that are vastly different from your background, those I think are workplace skills that are really, really more resilient than just the one tool.
You want to talk on workforce development or switch?
Sure. And actually I have a question related to that. So for, for those of us who may be recruiting, what could we do differently to help you guys, bridge that gap from students who are underrepresented in our disciplines to bring them into the workforce? What can we do to help?
So, me.
I can connect. So maybe I can connect what I have in mind on the workforce and then from the
Sure.
recruiter perspective. So I maybe keep in mind I'm talking about New Mexico. I graduated from Champaign, Urbana 9 years ago, and I moved to New Mexico. That is a different educational environment. So I'll describe it to you. It may be interesting. Our university is minority majority. So more than 50% are either Hispanic or Native Americans. That's the majority. Also, in terms of first generation students, that's the norm. And the state of New Mexico is the second in quality of high school education from the tail. So we are 49. So when I went to New Mexico, I identified that the student, I identify certain things that are still learning that maybe I can share. The minorities and the represented groups is a very interesting situation, and they are. And what I've been learning is that to engage them and to provide them a career, unless you approach and you need to approach them with different angles. So what I learn is that you need to give them more mentoring. That's common, but also you need to give them more diverse options about what is AI, what is programming, what is robots, and what is engineering, in my case. They respond when they see that in their group or in their research group or in their activity, there are different people because they see themselves being different, and that's what they are not used to see. So diversity is an interesting word, but you need to actually understand the students don't see that in the groups. They see it all the same. They say, oh, you're an engineer, you're in academia. So we need to encourage that different problems or diversity of problems for them to solve. I have one example. The national labs, they have very difficulties hiring Native Americans, and they still haven't figured it out. And I don't have the solution. I wish I could claim that I know how to do it, but if they allow the Native Americans to do research on the things that are important for Native Americans, then they will learn a lot from those skills. So we have a project with NASA in New Mexico, and they say, oh, we need to have the first Native American student group rocket. But it's so difficult. So, well, Native Americans are not interested in rockets. So it's better not to have goals to diversify the rocket competition that are not important. I mean, you need to allow them to, you may ask them, what do you think about space? And maybe they design something better than a rocket that we never thought about. So you need to allow them to tell you what are they interested in and have the table very open to do something that is not our goal. I think that's one thing that I don't identify. The last thing is interesting. So there is if you work with companies, recruiters, that they can identify themselves. So I work with a private owner, Phoebe Swina. She's the founder, president, economic leader, scientist of an environmental company. And then with NSF, I made her the salvaguardee. And when I hire students, they're going to work on that company with Phoebe Swina, and they actually stay with her after the project ended, and she hires them. And they are Native Americans that they would have never thought they would be building these sensors, but by having that environment, they thrive.
On what can, on the workforce side happen, I think there's a lot, I mean, come visit institutions that are minority serving institutions that are not flagships, right? I think that's a big one, because it shows people that industry wants people, not brands. So I don't want my Harvards. I want good lawyers, right? So in that vein, I think that a lot of the students in my experience, from minority serving institutions, and again, first generation college students, they usually have a confidence problem, right? So they left from high schools that were poor. They're bad, right? They're not very good high schools in terms of preparation, what we think, like how we prepared for university. So they come to university with a little trepidation. Usually their parents cannot help them at all, guiding them through the process of application and staying in the university. They're on their own. And on top of that, they have to compete with Harvard on the job market, right? So I think that the industry is, visiting them, making them understand that they finished college. Heck, that's a hell of a job, right? They deserve a job. I think that's really important. Visiting, coming to other schools, recruiting, not just for the sake of DEI, but for the sake of, hey, maybe you find that guy that invented the new way of finding something because he was thinking completely outside the box or outside your box, right? So
I would say a few practical, like instrumental suggestions. If you have expectations for an application, either for your lab or for hiring, make those very clear. So if you were requiring a cover letter and a resume and a statement of something, put that up there and make it very clear. When you move to an interview process, you don't have to give them all the questions, but give them some questions to prepare and to think about. Take those steps proactively, and you'll give everyone a fairer shot in the job hiring process. If you're recruiting for your lab, say your protocols for how you recruit for your lab and make those really transparent and really clear so that everyone can follow that same set of instructions. Again, those are small and instrumental, but for folks who don't have either experience sort of networking into a position or are very confused about like the steps on it, it makes a world of difference.
Yeah, I just want to reiterate that because another thing that identified that network that we take for granted doesn't exist in 80% of the that we're trying to help. So those instructions, like they didn't know what was graduate school. And this is the flagship university. And I just tell them you can get a research assistantship. The procedure is A, B, C. So those instructions, that was so important. So that the company is the same thing. If you explain more the steps and what are the consequences of sending this information, I will call you first on the phone and I will talk. They have no idea about this. Okay, I want to talk a little bit about the challenge that we are facing when we're recruiting students. So we find that because maybe, I don't know other state, but in Chattanooga, in the job market, it's a lot, industry, a lot of opportunity. So it's very challenging for us to keep students in the lab during the summer. Number one. The second one is the DSC, the scholarship. It's not an hourly pay. So it happens several times. Students get the first quarter of the scholarship and then just they disappear and never come back. So that's the challenge. That's why we just, I think it's a 2 extension. This is my second extension to apply. Thank you.
All right. Well, if you guys want, you want to have any comments on any of the other topics. So ethical considerations. We talked a little bit about sustainability and scalability in or interdisciplinary collaboration. Otherwise, I'd like to open it up to questions before our time is up.
that way I prevent questions. No, so one of the legs of our project involved working with multiple universities. And we've talked a lot about how we prepare students. But the collaboration between faculties that have radically different jobs, responsibilities, and ideas of what the job is a big endeavor. So if you have questions about that, he's here to respond. No, we're here to respond.
All right. Do we have any questions?
Hi, everyone. You talked a lot about underrepresented students and minority students. I'm curious if there's any steps you take in terms of non-traditional, specifically like non-traditionally aged students, parents, student parents, those kind of demographics. How do you support them in your programs? And if so, how do you?
So I can speak, and it is related to the interdisciplinary. Interdisciplinary is of all kind of levels. You know, in my group, I hire high schoolers and I pay them as young as sophomore in high school to people who are on their 50s. So I treat everybody, and this is my opinion, it could be wrong, I don't know if you're recording this. I think people respect when you treat everybody the same. And I don't know if that's correct or not, but that's what I explained to the 15-year-old girl that comes and she said, well, you know what, you're gonna learn, but I'm gonna expect the same from you. And for the 55-year-old that came from industries when I work with me, I say, hey, you're here to learn, you're here to ask questions what you don't understand. So I approach it that way. And I think the 55 and the 15 has been my experience. They respect that. They just want to come to a place where everybody's the same. They come here to learn, and also you enrich that you're here to learn from people who know more than you. And that's because they are in a different discipline, not because they're better. It's because they're doing. So I'm working with people who are not engineers, who are experts in education for these outreach activities. Daniel, he's education kid, and he's probably 26, finishing his undergrad. And he respects that he found something. So he's contributing because he loves the education in New Mexico. And he's not an engineer. He doesn't know anything about sensors. So everybody is here to learn. That's what I promote.
Hey, I know your programs are mostly about outreach and collaboration, but you guys mentioned things like, working with the mayor's board or underprivileged high schools. I'm curious if you, just in your opinion, you think there are changes at the public policy level that could be necessary and possible / practical, either through like just advising or lobbying or.
Well, I'm holding the mic. I say to my staff and I say to my students that data doesn't follow policy. And we have great evidence that data doesn't follow policy. And I think we often work in an expectation that we're going to put science out there, we're going to put data out there. There's going to be a policymaker out there who's like, I've been waiting for this. And then suddenly something's going to happen. But the political process is tricky. And the political process incorporates a lot of different viewpoints and a lot of different cultures and a lot of different perspectives. And we don't really want an entirely data-driven policy environment. That would be a technocracy. We would be making decisions a lot differently than we do in a democracy. So I think the best things that we can do, knowing that that path is never linear, is to really train our students to work in uncertainty, one, and two, to build those relationships. Because again, it's not what your data says, it's whether people trust your data. And it's whether you can be a good, trustworthy figure for getting that point across when the moment is right. And there will be like 3 moments in your entire life when that data is needed and when it's right. So I would just keep that in mind.
Since NSF is sponsoring this, I would say that, app score is great, but it's not enough. So it's good to have these incentives for underrepresented, but I need more funding for New Mexico. And I know NSF is supporting underrepresented and programs that try to, again, provide that environment for them or a special, as you say, what could be done differently. So, they are identifying that's one way to dedicate funding or programs for these communities. That's great. but we need more. So that's funding allows you to hire a, you know, as you say, a scholarship or something, but then when the scholarship ends, they you lose them. So.
I don't know if you want to say something about that.
Yeah, ours is interesting, I think, in that, I think governance for AI and such, and also for industry and the use of data and such is still in its infancy. That's my sense, is that, at the state and at the federal level, I think we're just starting to see policymakers wrestling with these things. I really think we're like in the pre-kindergarten stage there. So yeah, I'm also particularly interested in just understanding how the recent Supreme Court decision will affect admissions and the populations that we're seeing in our respective levels of institutions that we're working with in the next few years, and in the long run, of course. So please.
Jordan, have led to a very sustainable program, right?
Okay, yeah, we were talking about this last night, actually, in the poster session. So what I think one thing I really, really respect my colleagues are working with nonprofits and very communal oriented types of programs. I mean, there's a strong need and a place for that. And like my hat's off to them. And I also feel there's this need to reimagine how universities are working with the corporate world, with the national labs and what that pipeline looks like, and how students are weighing, okay, am I going to go to graduate school, or am I going to go right out to industry? And then what do I bring to the table? And do I have to be a data scientist, or can I be a domain expert with some data science skills, and all of that landscape, I think, is also continuing to evolve. So there's definitely a demand for the people in our workforce programs at all levels. We've spoken to the high school and community college level, and the undergrad and the grad and the postdoc level and so on. And like, wow, you go talk to any employer and they're just hungry to have this talent. They need it. Yeah. Like I'm a dinosaur now. Yeah.
So thank you very much. I think this has been a great discussion. I think the suggestions you're making to change the workforce, to make sure that people can be hired, they can be educated. But I want to make an observation, but I'm going to start with a story. So when I was director of African Studies at Princeton, we brought President Kagame to campus. And he said, after the genocide, I need to hire 10 to 20,000 teachers. And one of my colleagues said, well, we have some scholarships and we can bring some good qualified people to Princeton, and we can give them a degree in education and in science, and you'll have your science teachers. And he looked at that faculty member and said, you don't get it. One scholarship doesn't cut it. 5 scholarships doesn't cut it. I need 10 to 15,000 teachers. How are we going to get this done together? So the challenge that I have is we've got all these students from different communities that think differently outside the box. We need to find them jobs, but they have to have the skill set. They need to practice, they need to learn, and they need to do, and they need to have something on their resume that they've accomplished something. Now we, in imageomics, we have a 1-week boot camp. That's not good. NSF challenged us the first day for all the HDRs to work together. Why don't the HDRs get together for a 2-month summer program with business, with industry, bring kids to a place, 1,000 of them, and give them projects and education in STEM, in computer science, to solve real world problems in their communities? NSF will support that. That's the challenge. And that changes the scale that you're talking about there. Science projects, workforce development, real world applications, because they will tell you what the problem is about lead in their communities, or flooding, or river heights, as you talked about yesterday in your poster. They want solutions. How can AI help? How can predictive models give them confidence to change their actions and behavior for their own well-being? And so that's the challenge that I offer, not one or two, hundreds. Do it as a community of all the HDRs. Thank you.
Can I comment on that? We have 2,000 students in our program each year, but the thing that also, I mean, along those lines that I think about is, I don't think I have nearly as much to offer the students as my colleagues in industry do nowadays. I think it's very hard for the academy now to keep up because of the industry investments in the data science, and the students are smart consumers. Like, they get that from day number one, like, okay, the industry partner is much cooler than Dr. Ward. Well, absolutely. They're actually doing a lot of the learning, right? Like maybe the way we would have traditionally done a co-op, right? They're getting it directly from the industry mentor, but they're doing it while they're embedded in their college or university program, you know? And I think the academy has to continue to evolve and basically keep up with what's happening in industry.
Thank you. Thank you, the panel, for wonderful discussions. My name is Sanjay. I am from UMBC. Actually, I'm a co-PI on the HDR at UMBC, where Dr. Lucas, you're part of it. And thanks to Dr. Seema Iyer at University of Baltimore, and for you for the wonderful job you have been doing. My question is related to the sustainability and scalability. And I wanted to pick your brains on what you did during the pandemic, because it disrupted a lot of things. And especially the DSC was funded right before the pandemic started, right in 2019. And how did it affect your workforce development, especially your interaction with your communities? Everything changed, right? And what lessons you learned and how that can be taken forward for sustainability and scalability. Thank you.
It's interesting. I don't know, to share. I had the sensors and you know, we couldn't go to the native land because actually it was more strict there for obvious reasons. So we did everything on Zoom. So what I did, I put things on the envelopes and mail it to them. And we teach the class on the sensor, you know, just mail it to them. It's kind of more exciting that way, because you get something in your mail and you open it and you wait for the day that you start looking at it alone at night, and then you're waiting for the day that you're actually going to put the parts together. So it was very, you know, it was positive in some aspects. The students were sharing on their own. They spend more time on their own home, so they created a micro laboratory to build these things on their bedroom, you know, under the roof on their house. So they made it more of their own. Actually, it achieved that when it becomes more of their own idea, you know, it's it can reinforce their confidence. It can grow in a, you know, it becomes their own project. I have one last thing. I have one student had to stop the student to make more sensors because it was so creative that every time that we met, and I created this temperature sensor, this PDH sensor, this turbidity sensor, things that I never thought with him about. Say, and he did 30. I say, how many sensors have you? Say, I did 30. I say, no more, 30 types, because every week, you know, alone at home, knowing, oh, now I can build one sensor, I can build non-stop. So that in that sense, the pandemic on this student, it was like, well, I just ordered on Amazon, I create something, and I have to stop the creativity or the productivity. Say, well, let's do one and do it well.
So for us, one project during COVID was we needed to, one of the clients was a food bank in about 2.5 hours from Chicago. And well, it's sure, Zoom helps with the meetings and everything, but the two takeaways is one of the things we need to find out who goes to food banks, right? And for that one place to visit are churches. And churches aren't well documented anywhere in the area that was served in this territory. So actually one of the students made the trip. So I suggested people to make the trip. We couldn't make it together because of COVID. And one student actually made the trip, right? And then he came back with a story of how beautiful it was over there. Of course, no traffic makes things more beautiful, but it was beautiful over there and whatnot. He had a blast looking for churches in rural Illinois, right? And that's something that perhaps we would have all gone and visit the partner and let the partner tell us things. The guy went on a trip to visit churches, right? That's a good thing. Another thing that I will say that's separate from that is that I'm not saying that you faculty do this, but I've heard that some faculty are probably 1 or 2 weeks ahead of the students when preparing the class, right? And when writing the class. During COVID, you couldn't do that. I mean, because students can tell. So I think that regularity, giving clear expectations during COVID, at least for me teaching the course, was immensely important. I'm usually the one running 1 week ahead of the students. I did that the first 2 weeks. No, it's not going to work. So you put, elbow grease and you do the whole thing and you set clear expectations. So when they come, they have something for you and you have something for them every time.
So I came into this project, I inherited it from my predecessor in 2023. So we've had 2 accounts of like early pandemic creativity, which I think all of us can relate to. I'm going to give the 2023 perspective, which was end pandemic malaise across the board. People were tired of meeting on Zoom. People were going back to the office either begrudgingly or willingly, depending on your frame of reference. And students were really tired of virtual learning environments. So one of the things that we've done with the Data Core Fellowships is actually bring them back into the office, because we just realized that we couldn't maintain sort of the virtual support that we had been supporting during the pandemic, and sort of setting in-office requirements. Again, some of that has to do with some of the norms building that I was discussing earlier, which is if you're working in an office, you can learn about norms and interactions from your neighbors and you can bounce ideas off them quicker. And I think sometimes now we really take the hybrid Teams, email, video chat, all those things, we really take it for granted. But I think we've really learned to value, particularly when we're working with fellows, is that direct interaction in sort of helping them shape projects so they can bounce questions off of you and so that you can kind of set clear norms and expectations moving forward. So I think there is a spectrum of this.
Sorry, I want to talk a little bit just what we do about scalability. So our project is a large language model enabled like the music therapies. So in order to right now we only can just generate some music or relax the anxiety. So we hope like our work can be applied for the patient with stroke. That's why we just leave some redundant like the tokens, so that in the future we can continue, develop our work to can take care of the other disease. Another project is like we are working on the transportation management about the pedestrian and the vehicles. So we also just make our the data structure like more flexible, so that it can be applied to other cities, other areas. Thank you.
We're about at time. I have one quick question if we have time, or maybe not quick, but hopefully so people can get to coffee. It kind of cuts across scalability, interdisciplinarity, and workforce development. And so, I'm coming from the ecological and environmental data science domain. And so the conference I normally go to is the Ecological Society of America conference. We have a workforce development, underrepresented, early career development program across the street from Neon at the University of Colorado, where there's the EASL Synthesis Center. where they are also, they have development for bringing early career people into synthesis and thinking about co-production and bringing in underrepresented groups. And so I'm wondering, are there other initiatives that are maybe domain specific where, other people are thinking about this, and it's in the data science realm. It's in, like with EASL, so it's the environmental data science inclusion, what the other I is, lab, but it's basically, people that want to bring in ML and data science and ask environmental questions. So there are people that use the tools you all build that have similar initiatives. And I'm wondering like what kinds of silos you've been looking to break down to integrate with these other groups to tackle these problems.
Baltimore City in general, and I'm speaking for the city now, not the data science core, I think is actually doing a semi-decent job of training high schoolers, or at least providing opportunities into data science programs. We have Code in Schools, which is actually almost 10 years old now, and provides paid summer jobs to students to learn how to code. That's what they do for 6 weeks. And so I think that if you look into any city, I can't speak for anything but cities, but I think if you look into any city, you will likely find a lot of well-organized initiatives that have been going on for quite some time, who are trying to at least bridge this gap for the high school level. So I would just, again, turn locally and see what partners might be there. I know that there are also ones on the national scale as well, but you probably have some cool local partners that you don't even know about.
So I don't know about partnerships yet. And this, again, I'm not going to speak for the DSC that I participated, but there's a huge untapped source of data, and data is always data for what, right? I think there's an untapped source of data to improve people's lives, and data that is generated by, and you know this well, the mothers of your students, right? Or the people that are low literacy individuals that don't produce text like we do, don't consume text like we do, don't consume videos like we do, right? There's a whole host of applications waiting to happen. It's about 33 million Americans can read at a basic level. I think there's untapped resources there. I know some researchers that are trying to tap that, but I think that's a potential that is latent there.
Maybe I will add a flavor here from New Mexico. It's a very rural environment. So when we're talking about careers, nothing wrong with the city. I mean, the city of Albuquerque is big, but we don't have a industry. I mean, I should sell it better. We have industry, we have jobs, but not the same way that other locations. And the population is more thinking of a life in the rural environment. So we have a great help with the national laboratories, Los Alamos, Sandia, and the Air Force, but they actually fill that gap very well. But there may be people who are more entrepreneurs, or they would like to have a corporate career for themselves, for whether that's for many reasons, right? For a family, and it's a rural kind of job search adventure, because the traditional training that may happen in a society like your ecology or environment provide that, and there are, as you say, many opportunities to contribute for other environments or other states or other communities that don't have that support, career direction, or mentoring.
All right. If there aren't any other questions, I'll give you all a quick second if anyone has a question. Okay, then let's give our panel a round of applause. And I believe it's the coffee break.
Okay, can I make an announcement before we leave? Yeah, we have the coffee break out here. After the coffee break, we have 1 hour parallel sessions, breakout sessions. We have the machine learning challenges
one on NAIR and HDR Institute, how the HDR Institutes are gonna take advantage of NAIR. Then we have the interdisciplinary careers, and we have one that was the unconference had spoken yesterday. So we have one on model validation, interpretability, and UQ. And then there's one that Diana's leaving on this is an HDR student focus programming. The rooms are here. So these are the 4 breakout rooms, alma mater. And if you kind of go here, there's Lincoln. Remember, these are the breakout rooms you did before, loyalty, and then excellence. The HDR student focus one is here. Okay, so I just want to know, so I don't have to make announcements after coffee break. Just know after the coffee break, or even, a little early, you can start to assemble in those rooms. And in the breakout rooms, they're open now. And begin to start your work on on discussions and capture via the Google Docs that are provided via the links. If you don't have a leader in that room, I think most of them do, but some of them don't. If you don't have a leader, can you just find a leader to sort of lead the discussion or self-organize? For example, I don't see one in the AI data infrastructure. Last thing, after the breakouts, okay, you all have an email. It was bulletin number 8, I think, about the tour. So 45 of you signed up for the tour of the National Petascale Computing Facility. We are meeting the people there at the tour guide, who is actually one of our panelists, Brett Bode, at 5 p.m. at the front. We're going to buzz the door at 5 p.m., which means we have a little bit of commute time. It's a super short walk. It's mid-80s. It's sunny. We're going to walk as a group over there. So meet in the atrium at 4:45 so we can kind of come over as a group, because since we're going to be buzzed in, we need to all arrive at roughly the same time. So 4:45. If you're going on a tour today, leave the breakout room 15 minutes early, which is why you might go earlier. That's all I had to announce. So I'll just make sure you do these things without having to be herded. I do want to ask, could I talk to is Chaya here? How about Sai? Oh, Sai, could you come up here? It's not a public, it's just I want to talk to you after. You're not in trouble, I promise. And Malloy? Oh, he's outside. Okay. And then I talked to Josephine, right? Okay. Thank you. Go off to the coffee break, then the parallels, and then the tour if you're going to take it. Oh, I was just wondering. Okay, so I was looking at the roles, and there were 4 people that said they needed transport. Are you okay to walk? I'll be walking with all of you. I just wanted, I didn't, if there's an accessibility issue or just, so are you okay walking? You don't need to, because otherwise I have to find a car. Okay, you're good. Okay. And then, can you share? Oh, they are. So you know Malloy? Malloy? And then Josie and I talked to, and then the other one is, you know, Chaya? Oh, you're sorry, you're Chaya. And then. So all of you, we'll walk slow. It'll be no problem. I wanted to make sure I didn't have to get a car for everybody. Okay. No problem. Thank you. To the captioner, are you still over there?